Dear Secretary General, Dr. Kyriazopoulos, dear Deputy CEO of Port Authority of Piraeus, Captain Wang Ling, dear honorable guests, dear ladies and gentlemen, welcome, good morning. Welcome to the Green Sea Ports Conference. My name is Anna Leka. I am I am a member of the consortium team and honored to be moderating today's event. Green and Connected Ports is the full title of Green Sea Ports. It's an ambitious project trying to develop a wide series of digital technologies and innovations to support environmental sustainability at the ports of the TEN-T network. The project is co-funded by the Connecting Europe facility. It started in April 2019 and is expected to finish in March 2023. The project is jointly implemented by 12 partners from 4 European countries, Spain, Greece, Germany, and Italy, and is coordinated by the Valencia Port Foundation of Spain. Now, we are running in our third year of implementation now, so a set of outputs and results are readily available. Today's conference is going to focus on these outputs and the milestones accomplished so far, so looking forward to the presentations and exchange of views. Without further delay, I won't delay you anymore. I would like to invite our host, the Deputy CEO, Captain Wang Ling from the Port Authority of Piraeus, to address a welcome, and then we will proceed with the Secretary General. Thank you.
Good morning, everybody. Some are very old friends and colleagues. We take this opportunities, and our dear friends from the ministries. I just shortened this one. Everybody's very busy. That's one we can discuss the latest. I just take this opportunity to welcome everybody on behalf of the Port of Piraeus, and because such a project is an ongoing one, I still remember the last gatherings, that's part. So I did take this chance, the few words what we shared, and Piraeus ports, the functioning is one of the big ports in the Mediterranean, with the multi-functions. What I like to emphasize is it's a very unique in Europe, because we related to the cruise ships. Maybe everybody see. This is the one, the hot ports, the connecting, that's the port, the cruise business has been started. That's the hot season is back. Yesterday, the whole cruise piers was occupied. 5 very nice, fancy, the cruise was operated in Piraeus ports. Thousands of passengers is very happy to back to that part. That's the functions compared with the other ports in Europe. Is the other demands. Even we are working on this also EU fundings, this expansion on this the new piers parts has been working on the progress, is facing a lot of difficulty. But to meet that the futures the demanding, also this decarbonizations and the clean ports what we provide the such a service. I think this is a very necessity. I take this chance. And the other functions also we related, that's the public and the ferry domestic coastal parts. Piraeus port is very proud. We're still back to the very high levels compared with the years ago, even during the post-COVID periods. That's where related to 16 millions throughput for the passengers. I take this chance as related not only for the industrial functions, also related a lot of that's the public's interesting. So how demanding that's the parts. I just shortened this, the understanding what we are discussing for related that's the green ports, how important it is. And PPA has set up decarbonization plans until 2030s, aligned with the goals of the European Green Deals and Fit for 55 packages to reduce this greenhouse gas emissions and related parts by at least 55% by 2030, compared with the 1990 levels. Everybody's aware of. It's an ambitious goals for EU. Especially, it's not easy for us. But I think I just urge everybody, we have to work up, we have to boost to facing the truth. We must join all the force to achieve it. For Piraeus ports, the coal irons, that's related to a lot of the port operation, will be one of these the actions aiming improve the air and the noise qualities in the ports in the area and in the surrounding areas that be benefits the whole community. That's the parts we are working on it. We are on the right tracks. All the colleagues, the teams, struggling for this part. Recently, we are working out that's in action plans, also related a lot of the other issues. We try our best. So through this Green Seaports project, PPA has upgraded the exceeding the sensors, the networks of the atmospheres, the noise sensors, so on and so on. I just shortened this part. So I take this chance. I just hope our very nice teams could solid our technical support, and our toolboxes will be got more food to help such projects to move forward and to contribute to the whole societies in alliance still with the EU's one. So I just shortened this one because the General Secretary is really urged to some of them. We can discuss it later. I just hope the conference could be very successful. Enjoy this day. Thank you.
Thank you, Captain Wang. The General Secretary of Ports, Port Policy and Maritime Investments of the Ministry of Maritime Affairs and Insular Policy, Dr. Kyriazopoulos.
Thanks a lot. I agree with you. Yesterday was a very nice, beautiful day for Port of Piraeus. I have too many pictures from cruise ships, you see. I have a nice view from my office, so I see all these nice cruise ships that come yesterday to the Port of Piraeus. Ladies and gentlemen, I am happy to be at this important event for the port community. First of all, congratulations for the success of the Green and Connected Port project. I'm happy to say that it was our General Secretariat that gave the first green light for the proposal of this award-winning project. Piraeus Port is one of the 5 main Hellenic ports of TNT network. That's why projects like this are important to shaping our national transport policy. And today our national policy is more connected to the environment than ever. In fact, our maritime transport policy was completely transformed. It now follows the European Union's goals to first reduce greenhouse gas emissions at least 55% by 2030, and secondly, to achieve the climate neutrality by 2050. For example, between 6 and 7% of carbon dioxide emissions are created at berth when the ship is standing in the port. This especially shows that we need to make our ports green. To achieve this, the European Union has 3 main goals: the greening of shipping, the sustainability of port services, and the infrastructure of alternative fuels. The regulation of the alternative fuels infrastructure is looking to create a solid alternative fuel network, including liquefied natural gas in all EU ports. However, high investment on ports for an alternative fuel infrastructure are needed. The Commission believes that the total cost of investment from 2025 to 2050 will be around 10 billion euros. So, let's talk about the financial options available to achieve these goals. Although I don't believe that there is enough financing available to cover these needs, let me talk about the possible tools to make our ports greener. First of all, your instrument, the well-known Connective Europe Facility, which we continue to finance until 2027, actions relating to the maritime ports, multimodal logistics platforms, and motorways of sea program. Secondly, there is also the Alternative Fuel Infrastructure Facility that supports three key areas: renewable energy, green hydrogen, and circular economy. With 1.5 billion euros until 2023, the program provides funding for three types of recharging and refueling infrastructure, including LNG, electric and hydrogen refueling infrastructure, also for short sea shipping vessels. Furthermore, another possibility for financing maritime projects is the Innovation Fund. This fund will provide 20 billion euros for new low-carbon technologies, and it has already invested 118 million euros into 32 projects in 14 different European Union countries. The most impressive projects financed by the fund are the use of green hydrogen from renewable sources for zero-emission vessel, low-carbon bio-liquefied natural gas for maritime transport, and wind-assisted technology for a cruise ship. Of course, a big part of the funding for greening of ports need to go to research to find better answers about which maritime fuels in the port infrastructures are needed. Thus, the Horizon Europe program will provide 95 billion euros in co-funding for research and innovation projects, part of which will be for environmental friendly transport projects. A great action is also the zero-emission waterborne transport partnership, will focus on developing the first zero-emission vessel by 2030. So, as we can see, there are many possibilities available. Although the situation in Ukraine may slow down developments and investments, the time for change in maritime transport and ports is now. With this in mind, unfortunately, I will have to leave now. I have two more obligations, and because there are many other speakers waiting to speak after me. Thank you very much. I wish you great discussion about the green of ports and the opportunity ahead. Thanks a lot. Sorry. Okay.
Thank you, Dr. Kyriazopoulos. Unfortunately, we will have to excuse the Secretary General as he has another conference to attend. Okay, moving on. Our next speaker for the welcome address is Mrs. Antonia Karakatsani. She is the Deputy Mayor of the Municipality of Piraeus. She is responsible for the environment and landscape issues. Ms. Karakatsani. She is going to do her presentation on behalf of the Mayor, Ioannis Moralis, who could not attend today. Her presentation is going to be in Greek, but we are going to illustrate the English version on the screen for your convenience. Thank you.
Θα αλλάζουμε εμείς.
Όχι, θα την αλλάξει. Ποιος είναι υπεύθυνος. Κάθε σελίδα που τα προχωρικά.
Να το βάλουμε να παίξει.
Ναι. Καλημέρα σε όλους και όλες. Είναι μεγάλη μας τιμή που σας φιλοξενούμε στην πόλη μας. Ως Αντιδήμαρχος της Διεύθυνσης Περιβάλλοντος και Πρασίνου, σας καλωσορίζω στη φιλόξενη πόλη του Πειραιά, εκ μέρους του Δημάρχου Πειραιά, κ. Γιάννη Μόραλη, ο οποίος δεν κατέστη δυνατόν να παραστεί εξαιτίας επίγουσας υποχρέωσης. Είναι χαρά μου που βρίσκομαι σήμερα εδώ, στην ημερίδα του Ευρωπαϊκού Έργου, Green Seaports, υποστηριζόμενο από το πρόγραμμα της Ευρωπαϊκής Ένωσης, με τόσο σημαντικούς εκπροσώπους φορέων χωρών της Ευρωπαϊκής Ένωσης, που ενεργοποιούνται σε τομείς του τουρισμού, των μεταφορών και των λιμενικών δραστηριοτήτων γενικότερα, αλλά ταυτόχρονα συμμετέχουν για χάρη του περιβάλλοντος. Σε δράσεις που μόνο θετικά συνεισφέρουν στο βιωτικό επίπεδο των πολιτών των ευρωπαϊκών πόλεων. Θα ήθελα να χαιρετήσω τους Ευρωπαίους εταίρους και να συγχαρώ ιδιαίτερα τη συντονίστρια αρχή της δράσης στον οργανισμό Λιμένος της Βαλένθιας για τον άριστο συντονισμό των δράσεων υλοποίησης του έργου. Θα ήθελα να συγχαρώ επίσης όλους τους Έλληνες εταίρους του έργου και κυρίως τον οργανισμό Λιμένος Πειραιά για την άψογη διοργάνωση της ημερίδας, αλλά και να τους ευχαριστήσω για τη δραστηριοποίησή τους στο λιμάνι του Πειραιά και τη συνεχή προσφορά τους στην ανάπτυξη της πόλης μας. Συμβολή του Δήμου και του λιμανιού του στην οικονομική ανάπτυξη. Ο Πειραιάς αναπτύσσεται ταχύτατα και εξελίσσεται σε ένα σύγχρονο λιμάνι υψηλών προδιαγραφών. Από την πρώτη στιγμή της θητείας μας, ως Δημοτική Αρχή, διακηρύττουμε την τεράστια σημασία που έχει η θάλασσα για την οικονομική ανάπτυξη της πόλης μας. Άλλωστε, το 37% του εμπορίου εντός της Ευρωπαϊκής Ένωσης διεξάγεται δια θαλάσσης. Ενώ το 2021 το λιμάνι του Πειραιά ήταν στην 29η θέση παγκοσμίως και στην 5η θέση στην Ευρωπαϊκή Ένωση. Στον Πειραιά συναντώνται δύο σημαντικοί παράγοντες της παγκόσμιας αλυσίδας. Ο ελληνικός εφοπλισμός και η μεγαλύτερη εξαγωγική βιομηχανία, η Κίνα. Παράλληλα, ο Πειραιάς αποτελεί έναν κόμβο θαλάσσιο μεταφορό σε υψηλή ειδίκευση. Περιβαλλοντικές επιδράσεις των λιμενικών δραστηριοτήτων. Δυστυχώς, σχεδόν όλες οι έντονες λιμενικές δραστηριότητες έχουν αρνητικό αντίκτυπο στο περιβάλλον της εγκύτερης περιοχής, ενώ τα ίδια λιμάνια είναι ευάλωτα σε μελλοντικές αλλαγές στο κλίμα, λόγω της προβλεπόμενης αύξησης της στάθμης της θάλασσας, σε χρονικό ορίζοντα ίσως και μόνο μερικών δεκαετιών. Υπό ορισμένες συνθήκες, η ατμοσφαιρική ρύπανση μπορεί να φτάσει σε επίπεδα που μπορούν να δημιουργήσουν από ανεπιθύμητες συνθήκες διαβίωσης έως και μακροχρόνια προβλήματα υγείας. Συνεπώς, η παρακολούθηση της ποιότητας του αέρα, αλλά και των επιπέδων θορύβου σε μια αστική περιοχή, όπως είναι ο Πειραιάς, που εμπεριέχει ταυτόχρονα σημαντικές λιμανικές εγκαταστάσεις, αλλά και συναφείς επιχειρήσεις, είναι θεμελιώδη σημασία. Ο Δήμος Πειραιά δεσμεύεται ότι για την αντιμετώπιση της ατμοσφαιρικής ρύπανσης στην περιοχή του λιμένα, σε συνεργασία με τον ΟΛ, αλλά και τους αρμόδιους φορείς, θα συνδράμει ώστε να ληφθούν τα εξής μέτρα. Πρώτον, συνεχής έλεγχη της ποιότητας καυσίμων των πλοίων με τη λήψη δειγματοληψιών. Δεύτερον, χρήση καυσίμων ειδικών προδιαγραφών στο περιβάλλον για πλοία που κινούνται εντός του λιμανιού. Τρίτον, συνεχής έλεγχη επιθεώρησης της κατάστασης των μηχανών των πλοίων, ώστε να διαπιστώνεται αν έχει γίνει γνωστή συντήρηση. Τέταρτον, εκπώνηση κυκλοφοριακής συγκοινωνιακής μελέτης σε ευρύτερης περιοχής του λιμένα, με σκοπό την αποφυγή της διέλευσης οχημάτων εντός της πόλης του Πειραιά. Πέμπτο, αυστηρούς καθημερινούς επιτόπιους ελέγχους εκπομπών καυσαερίων σε όλα τα οχήματα που διασχίζουν την περιοχή του λιμανιού. Έκτο, δημιουργία δικτύου σταθμών μέτρησης ατμοσφαιρικής ρύπανσης εντός των διοικητικών ορίων του Δήμου Πειραιά. Από το 2010, μετρήσεις ατμοσφαιρικής ρύπανσης για την περιοχή του Πειραιά διεξάγονται από το δίκτυο σταθμό μέτρησης ατμοσφαιρικής ρύπανσης του Υπουργείου Περιβάλλοντος, με κίτρινο και μπλε χρώμα. Από το 2018 διεξάγονται εξειδικευμένες μετρήσεις ατμοσφαιρικής ρύπανσης στην οροφή του τερματικού σταθμού του ηλεκτρικού τρένου, πορτοκαλί χρώμα, πλησίων του λιμένου Πειραιά. Ο Δήμος Πειραιά εφαρμόζει διαρκώς εθνικές αλλά και ευρωπαϊκές δράσεις, στοχεύοντας τη μείωση των περιβαλλοντικών επιπτώσεων των λιμενικών δραστηριοτήτων. Λαμβάνοντας υπόψη μας, η Διεύθυνση Περιβάλλοντος και Πρασίνου του Δήμου Πειραιά ανέλαβε με ιδιαίτερη χαρά τη συμμετοχή στην υλοποίηση του καινοτόμου έργου Green Seaports το Μάρτιο του 2019, γνωρίζοντας ότι μπορεί να φέρει εις πέρας μια τόσο απαιτητική πολυσύνθετη δράση. Στο πλαίσιο του έργου, ο Δήμος Πειραιά έχει εγκαταστήσει από τις 3 Δεκεμβρίου του 2020 δίκτυο μετεωρολογικών και αέριας ρύπασης αισθητήρων. Θέλω να πω, έχουμε τη βράβευση του Δήμου Πειραιά. Είμαστε στην ευχάριστη θέση να σας ενημερώσουμε ότι ο Δήμος Πειραιά τιμήθηκε ανάμεσα σε πολλούς υποψηφίους Δήμους της Ελλάδας για τη συμμετοχή του στο έργο του Greece Imports. Πιο συγκεκριμένα στο πλαίσιο διεξαγωγής της 4ης Διεθνής Έκθεσης Τεχνολογίας Περιβάλλοντος από τις 18 έως τις 20 Μαρτίου του 2020. Του απονεμέθηκε το βραβείο ελέγχου μέτρησης ποιότητας ατμοσφαιρικού αέρα στην κατηγορία αέρια ρύπανση. Ωφέλη από τη συμμετοχή του Πειραιά στη δράση Greece Port. Ο Δήμος Πειραιά, στο πλαίσιο υλοποίησης του έργου, θα συνεισφέρει εμπράκτως στην επίτευξη των στόχων του για την αειφόρο και βιώσιμη ανάπτυξη, την προστασία του περιβάλλοντος, τη μείωση των περιβαλλοντικών επιπτώσεων των λιμενικών δραστηριοτήτων, αλλά και τη βελτιστοποίηση της αποδυτικότητας των δραστηριοτήτων αυτών. Ως Δημοτική Αρχή, δεσμευόμαστε ότι θα συνεχίσουμε να αναλαμβάνουμε παρόμοιες πρωτοβουλίες για την προστασία του περιβάλλοντος. Συνοψίζοντας, το όραμα της Δημοτικής Αρχής για την ανάπτυξη της πόλης ως επιχειρηματικού και τουριστικού και μητροπολιτικού κέντρου διεθνούς αναγνωσιμότητας και εμβλέβειας παραμένει ζωντανό. Παράλληλα, δεν λησμονούμε και τους στόχους περιβαλλοντικού χαρακτήρα, συμβάλλοντας έτσι στη βασική επιδίωξή μας, που είναι η βιώσιμη ανάπτυξη σε όλους τους τομείς που δραστηριοποιούνται εντός και περί του λιμανιού μας, τους κατοίκους, εργαζόμενους και επισκέπτες της πόλης μας. Σας ευχαριστώ και πάλι για την παρουσία σας και τη συμμετοχή σας και ελπίζω να έχετε μια ευχάριστη διαμονή στην πόλη μας στις επόμενες μέρες. Σας ευχαριστώ πολύ.
Thank you very much, Mrs. Karakatsani. Going to our next and final speaker for the first session, I would like to welcome Mr. Stefano Campagnolo. He's the project manager of Green Sea Ports in Sinea. He's a project manager in a number of ports dealing with multimodal and multi-fuel components. Mr. Campagnolo is joining online today. So, good morning.
Good morning.
We can hear you.
Morning.
Yes, good morning. We can hear you.
Perfect.
Thank you.
I will just share my PowerPoint presentation that I prepared for today.
Thank you. We're waiting.
Is it visible?
Yes, it is. Thank you. Go ahead.
So, good morning from Brussels. I wish to thank everybody before starting, in particular the Fundación Valencia Port, the Piraeus Port Authority, the Municipality of Piraeus, and all those involved for the organization of these 2 days. Unfortunately, I cannot be with you in physically, but at least there's the possibility to speak to speak remotely. Today is an important day and a milestone for this project. Indeed, this is the second public event and the first, as far as I know, at least partially in presence, to share the experience and the concrete results of Green Sea Ports, and in particular, the successful installation of the environmental sensor, their integration on the existing monitoring system, and the development of the port environmental performance platforms in 5 core ports: Piraeus, Bremerhaven, Wilhelmshaven, Valencia, and Venice. This event is therefore an opportunity to make visible also the initiative supported by EU to improve the sustainability of ports for both the cities that are hosting them and the operators involved, while ensuring smooth and efficient transport flow towards their capture areas. Like this event, my intervention will be somehow hybrid. First, indeed, I'm going to talk more and to not show many slides, when I will touch upon why Green Sea ports is still an actual project, to later focus on the ongoing funding opportunities under CEF program, the one that are available for you today. So Green Sea Port has been conceived already in 2018 and founded in 2019 under a different scenario. Before what we know, the two main game changers, the COVID-19 outbreak and the geopolitical tensions which are affecting now the energy markets. It has been awarded of a fund of more than €3.5 million of EU contributions. Why? Because of the highly innovative idea of linking the measurement of emissions and weather conditions to improve transport flow. Hence, Green Sea Port will significantly contribute to innovation, sustainable transport, and decarbonization, overcoming existing critical aspects by improving the efficiency of port operation, promoting environmental sustainability of ports, the environmental performance, as well as their operation, and improving the connection to the cities. Therefore, it is aligned with the 10th priority, especially for what it matters efficiency and sustainability. The expectation of the impact from this project are also very significant. Indeed, through the sensor deployed, the port environmental platforms, and the model supported by artificial intelligence, key information would be available to a wide array of stakeholders, port operators, public authorities, customers, municipalities across the 5 main ports, as well as improving economic and environmental performances, while reducing negative externalities such as congestion, emissions, which create tensions sometimes with cities that are next to the ports. Now, after the first phase, which I assume it has been a little bit bumpy also due to the unprecedented events we mentioned above, the COVID-19 outbreak and later on the geopolitical tensions, the agency is looking forward towards the last year of implementation and the most exciting phase, the full execution of the 6 case studies foreseen and the later study on the possibility to replicate this experience across the EU. Indeed, an initiative like Green Sea Port is extremely important for the EU since it addresses 2 key priorities. First and foremost, the climate change, as well as a new emerging priority, which is energy security. In particular, when talking about climate change, we know that measures at global level are necessary to fight the rise of temperature. To do so, there's only one way, which is extremely challenging, a monumental challenge, a societal challenge, decarbonization, which is not limited to the transport sector only. And to overcome these challenges, the European Green Deal, adopted at the beginning of the term of this Commission, aimed to transform the EU into a modern, resource-efficient and competitive economy. And as you already know, it will make also Europe the first climate-neutral continent in the world by 2050. This is the goal, and it is even more urgent now due to the tensions which are affecting the energy markets. Transport is one of the sectors with the highest growth of emission and other pollution elements in the past decades, since it makes use mostly of fossil fuel and in particular of oil. Therefore, to achieve the goal set by 2050, a reduction of 90% of greenhouse gases emission from transport is necessary. And it goes without saying that this entails dramatic changes and it cannot happen overnight. Measures to support the transition and accompanying all transport modes are necessary. Nevertheless, this has to happen now very fast when the technological solutions are available. And for technological solution, it doesn't mean necessarily to be a breakthrough, but it can be also a technology aiming at making a more efficient use of resources and to optimize the use of existing infrastructure while reducing energy consumption and improving the environmental footprint of operations. In a word, technologies that helps to reduce the negative externalities associated to the infrastructure. And this is ultimately what beneficiaries are trying to achieve with the Green Seaport Action. Maritime transport and related infrastructure here has a key role, since this modality is carrying the majority of goods, 80% in metric ton per kilometer traveled every year, and is the most efficient use, although is using only fuel derived from oil. Therefore, the first step towards this transition to support decarbonization had been already taken, and the European Commission is committed to the objective through several measures like proposals, legislative proposals, and as well as funding and supporting the transition. In particular, resources have been set up, as you can see in the slide, with, among others, since last year, the executive agency has been created, SINEA, to support the European Climate, Environmental and Infrastructure funds. The European Commission has entrusted this agency, SINEA, with a budget of 55 billion. You can see here all the project, all the program management, which are not limited only to transport and infrastructure. And it is linked to the Green Deal, and it is necessary to implement the strategy, objectives, and priorities in the areas that EU has set. And to support this transition towards a lower carbon economy, already the funding program has started. In particular, the Connecting Euro facility is a key funding instrument to promote growth, job competitiveness through infrastructure investment on the Trans-European network for transport, energy, and digital services. And as you know, the CEF program has been implemented since 2014 with a budget of around 30 billion, 24 of which went to the transport sector and contribute actively to the European transport infrastructure policy. For the maritime sector in particular, CEF transport has been the traditional funding sources for studies and works related to maritime infrastructure project on both on the core and the comprehensive network, including the motorways of the sea concept. During the period 2014-2020, 152 actions have been founded in 119 maritime ports, receiving 1.67 billion of EU contribution. And when it comes to the innovation and new technologies under which Green Seaport was selected, CEF focused on market study innovation, notably it supported technologies sufficiently mature and at the end of their research and development phase to test their business model through pilot deployments to pave the way for further rollout and mass market. And since 2017, action targeted digitalization and the rollout of supply of alternative fuel infrastructure. In the latter case, because the technology reached a good maturity level. In total, more than 200 actions have been financed, representing slightly less of 5 billion of investment and close to 1.3 billion of CEF contribution. And the funding from private sector has progressively increased within the blending concept. Now, as you can see, the CEF2 program is running from last year, 2021 to 2027, with an overall budget of 33.71 billion, targeting again transport, environment, and telecom for completing the network, modernization, and also with an eye to civil defense, the so-called dual use. As you are probably aware, the first main call has been closed on 19th of January, making available 7 billion for projects aiming to build, upgrade, and improve the European transport infrastructure. Nowadays, the evaluation phase is being finalized and results will be communicated after the decision of the CEF committee at the beginning of this summer. However, the envelopes for different call and topics were stable as agreed in the implementation. Therefore, for the first 3 calls, namely the one that just passed and the next 2, related the envelopes are stable, and therefore more information can be found on CINE website, especially on the multi-annual program. And the second call for proposal will be launched in the forthcoming season. Talking more concretely about the funding opportunities for maritime and waterborne transport, you can see in this slide a summary with what can be financed. In particular, CEF2 supports initiatives to increase sustainability for the support and the reduction of greenhouse gases emission and negative externalities like alternative fuels, onshore power supply, and other emission-reducing technologies. It will also support initiatives to develop smart and interoperable transport, namely aiming to a wider digitalization, including also through better digital tools such as European Maritime Single Window, data sharing among operators, and other traffic management solutions like the Vessel Traffic Monitoring System, the VTMIS, or the River Information Service. It will also contribute to make seamless transport happening, including investment in physical infrastructure, both in ports and for improving the inland connections. As well as it will support action to ensure resilience, like fostering digitalization, strengthening port infrastructure, and including in the planning of the infrastructure, connections that are resistant to disruptions. However, nowadays, as I said, there is still a funding opportunity under CEF2, which is notably the open call on alternative fuel infrastructure facility, known as AFIF, which has an indicative budget of 1.5 billion euro. These include also the cohesion envelope. This addresses the topic of low and zero emission fuels. The objective is to focus on zero emission fuel for transport, notably electricity and hydrogen, with a 30 and a 50% compounding rate, as well as transition on low emission fuel, limited this only for maritime transport and inland waterways, up to 10% funding. You can see indeed from this slide that the AFIF has 2 priorities, but the one we are focusing in are the topics on zero emission and low emission fuel, because the so-called unit cost addresses only road transport. AFIF has 2 particular issues or features that makes it different from other CEF calls. The first one, that it is a rolling call, meaning that, as you can see, you can have continuous cutoff dates. One has just passed, but another is approaching soon, so from the 7th of June. And this will have sufficient time to beneficiaries to prepare the application. Furthermore, the second particularity is the need of financial agreement with an implementing partner or with a non-implementing partner that has to be provided at the moment of the application to stimulate, to show that there is a real commitment and a mature commitment with a due diligence carried out for having a financial contribution, and has to be signed before the signature of the grant agreement in order to stimulate and attract private capital. Here, as I mentioned, you can see the co-funding rates for the cohesion envelope and for the general envelope, 30% up to 30% and 50% in for electricity, while 10% in 20% are left for the LNG, for the low emission coal. Without entering too much in details, I have prepared two slides that shows what actually is going is eligible for inland waterways and also for maritime port areas within the TEN-T. So for the electrification of transport, there is on one hand the recharging stations to supply inland waterway and maritime vessels, such as OPS or and the related grid connection, as well as to support vehicles and equipment used in operations. However, it is not possible to finance directly the vehicles and equipment unless there is a business case that shows that this is necessary to create and to feed a market, as well as only the difference between the cost of traditional fuel equipment and zero emission equipment will be available, will be eligible. And to not make it too long and too details, but also hydrogen in the same priority can be financed both for the infrastructure to recharge, to fuel the vehicles, including also the operational vehicles, and the same conditions applies as for the electricity. Namely, that only the difference between for the vehicles only if necessary for justifying the business case, and only if there is a business case behind with eligible costs as fossil fuel and the difference between conventional vehicles equipped by fossil fuel and zero emission vehicles. And for the LNG, this, of course, it is a mature and a transition fuel, therefore the co-financing rate is lower. Storage and bunkering vessels are eligible within this priority. And of course, priority will be given to action demonstrating a progressive uptake of bio-LNG, which has a lower emission than that conventional ING. And this is the end of my intervention because I don't want to enter, as I said, too much in details. You can find all the information on CINEA website. And I invite to contact through the normal channels the agency and the European Commission in case you need further clarification, as well as to follow if you are thinking to prepare an application, the frequently asked question, which clarifies even better the possibilities and the technicalities of the code. Thank you very much again, and I'm looking forward to next speakers to have more insight on the development of the case studies and on the work done. Thank you very much.
Thank you very much, Mr. Campagnolo. We have now concluded with the speakers, so I will open the floor for discussion. I don't know if we have any questions in the room or through our online participants. In case we do have questions, please just raise your hand and we will bring you a microphone. And in the case of the online participants, kindly put your question in the chat and we will just read it aloud. No? So everything was clear? Δημήτρη, έχουμε κάποια ερώτηση? Ωραία, οπότε το ολοκληρώνω.
I think we have questions
During the presentations, definitely. Okay, so I will now conclude the first session. Thank you to all the speakers for their enlightening presentations. We will take a break of half an hour. Please feel free to get your coffees and beverages right outside the conference room. For those who were delayed, I kindly ask you to sign the participants list right outside the conference room. Thank you very much. Half an hour. Coming back to the conference, we are initiating our second session. The second and third sessions are going to focus on the results of the case studies of the Green Seaports project. The second session is going to present the overall objectives of Green Seaports and the first 3 case studies. I immediately give the floor to our coordinator, our project coordinator, Mrs. Eva Perez from the Valencia Port Foundation. Eva is going to be joining us online. I don't know if she can hear us.
Hello, good morning.
Good morning. Mrs. Perez has more than 20 years of experience in such projects. She has an expertise in R&D in the fields of environmental sustainability, net zero strategic planning for ports, alternative fuels in the port maritime logistics sectors, motorways of the sea, and feasibility analysis of transport infrastructure. Eva, can you hear us? Great, we can see you.
I hear you perfectly well. Can you hear me?
Yes, good morning, Eva.
Good morning.
Welcome.
Thank you. Well, good morning, everyone, and thank you very much for the introduction, Anna, and also thanks a lot to the Port Authority of Piraeus and the Greek partners for organizing this event and hosting it in Piraeus. Before I start with my presentation, I'd like to excuse ourselves, and I'd like to explain why Fundación Valencia Port is not attending in person this meeting. As all of you know, climate change is a global emergency, and in Fundación Valencia Port, we are firm believers that we need to act now. We want to contribute to mitigating climate change by reducing as much as possible our emissions, and as an organization, and therefore we have adopted a travel policy that implies that only one representative of the company will attend communication events and meetings in person. My colleague Joanne was going to attend on this occasion, but unfortunately he's got COVID and he was still positive 2 evenings ago. So as a result, no member of our team has been able to attend today in Piraeus. In future events, one representative of Fundación Valencia Port will be attending, COVID permitting. So I'm going to introduce you the project, Green Seaports. First of all, we'll talk about the context in which this project is being carried out. In section 2, I'll introduce the consortium and the project's objectives. In section 3, we'll analyze the project activities, and then we'll review briefly the case studies. Finally, we'll talk about communication and coordination, and mainly we'll focus on future communication events. So there is a clear commitment of the European Union that transport should become drastically less polluting. And they are highlighting the urgent need to reduce greenhouse gas emissions in aviation and waterborne transport. Waterborne transport represents approximately 75% of global trade. And in the specific case of the European Union, 79% of our exports and 75% of our imports are transported by sea. So the relative importance of shipping in Europe is even larger than globally. Consequently, waterborne transport accounts for 13% of the EU transport greenhouse gas emissions and is experiencing continuous growth. Given the importance of ports as interconnection points in transport networks, but also as major multimodal nodes, logistic hubs, and commercial sites, linking with other transport modes, hinterland connections, and integrated with cities, there is a clear need to preserve these important economic functions whilst reducing transport greenhouse gas emissions. The new regulatory package proposed by the European Commission, the Fit for 55, clearly establishes the goal to cut by 55% emissions in 2030, in comparison to 1990. And the European Union Green Deal strategy and climate law have clearly set up the goal to become a climate neutral continent by 2050. So the goals are very ambitious, and we are going to see how Green supports and how this consortium is responding to these challenges. So the Green Support Global Project aims at creating digitalization tools and technologies to support port environmental sustainability and performance of port operations in the TEN-T core network. We are working in 4 ports of the TEN-T network: Piraeus, Venice, Bremerhaven and Wilhelmshaven, and Valencia. And our partners are in Germany, DBH, who is the manager of the port community system of the ports of Wilhelmshaven and Bremerhaven. In Italy, the Port Authority of Venice. In Spain, Inerco, Gas2Move, Balearia, the Port Authority of Valencia, and Fundación Valencia Port. And in Greece, Global Maritime Enterprises, Centravel, ICCS, the Municipality of Piraeus, and the Port Authority of Piraeus. So we have got together to work on the goals that you can see in this slide. We have both environmental objectives and technical objectives. On the environmental side, our goal is to decrease port traffic congestion. The case study is going to be carried out in Valencia, and we have quantified that we would like to decrease port traffic congestion by decreasing the CO2 emissions by 10% of trucks entering and leaving the Port of Valencia. Optimizing vessel calls. The case study here is carried out in Venice. So we're going to optimize vessel calls in the Port of Venice before and after port closure due to bad meteorological conditions. We are also aiming at predicting air quality and noise levels, both in the ports of Valencia and Piraeus. And we are going to generate notifications to governmental institutions. Predicting how ship-to-shore crane productivity will be affected by, again, meteorological conditions, and warning with 24 hours of anticipation, vessels programmed to call at the ports of Wilhelmshaven and Bremerhaven. Informing shippers about real emissions in pilot door-to-door transport chains between Valencia and the Balearic Islands, and communicating effectively the case studies that we are carrying out and the many benefits that we are obtaining. On the technical side, we are going to upgrade existing sensor networks, and we are going to install new sensors in the ports of Valencia, Venice, and Piraeus. And we are developing, well, we have already finished this first milestone of implementing a port environmental performance platform, gathering real-time data from the sensors and also from other operating systems in the port. This is the general scheme of the project. So we are connecting the new sensor networks, existing sensors, and also other systems like the port management information system, the port community system, and the terminal operating system. And all of these are being connected to the newly created port environmental platform. We have already finished this first activity. We are going to present to you the details of all the work we've been carrying out in this event today. And we have already started activity 2, in which we are gathering all this information and applying business intelligence, big data analysis, and artificial intelligence predictive modeling to 6 case studies. I'm going to talk briefly about the 6 case studies in a few slides. all this information that we are gathering, processing, modeling, we are going to report to both internal and external users. On the internal side, there are several departments in our port authorities that are interested, like port strategy, port operations, port environmental affairs, and there are also many external users that are interested in this project: shippers, terminal operators, trucking companies, freight forwarders, sea carriers, harbor masters, city council, and neighborhoods. So concerning activity 1, which is the focus for today's event, we have carried out several tasks in order to complete the goals for this activity. The first thing we did was to specify the IT requirements for the sensor network and the port environmental platform. Then we installed in the ports of Valencia, Venice, and Piraeus new environmental sensor networks. We've implemented in all the ports in the consortium the port environmental performance platform. This platform has been end-to-end integrated with existing systems, like the ones we see in the slide, and with the new sensors. We have defined a validation plan with different test scenarios and test cases, and finally we've validated that this port environmental performance is receiving the information accurately, and that we have also been able to validate all the scenarios and the cases that we are going to use this platform for. In activity 2, which we have already started, we are we have analyzed all these different sources of information, all these variables, fields of information, in order to check for outliers, for mistakes, for errors. And once we've cleaned up these different data sets, we have prepared the ones that we are going to use in the development of the artificial intelligence models for prediction. And we are also going to evaluate the quality of those predictive models as the final task in this activity. In activity 3, we have already defined processed information reports. So we've been talking to the internal and external users of all this information to see how they want to receive all this data, all this information. And we have also implemented reporting mechanisms. We are in the process of implementing reporting mechanisms. In task 3 in this activity, we're going to manage the platform, and we are also going to be reporting to the city and to different stakeholders. And finally, we are also validating that the reporting modules work properly. Some examples of reporting modules are the ones that you can see at the bottom of this slide. There is a module for truck drivers to inform them about traffic congestion in the Port of Valencia, real-time information for cruise and ferries passengers about ship delays due to weather conditions in Venice, modules on air quality and noise for municipalities and neighborhoods in the ports of Piraeus and Valencia, a module for sea carriers and terminal operators to inform on foreseen terminal productivity that may be lower than expected due to weather conditions in Bremerhaven and Wilhelmshaven, and a module for shippers to follow the real emissions generated by transport, door-to-door transport chains for their shipments. And this is going to be done again in Spain, between Valencia and the Balearic Islands. So our case studies are the ones that you can see here. Case study 1, decreasing port traffic congestion. The second one, improving maritime accessibility to ports. The third one, it's improving air quality in ports and port neighboring areas. The fourth one focuses on reducing noise. The fifth one, forecasting ship-to-shore crane productivity. And case study 6, carbon footprint in multimodal transport chains. So measuring and informing about real emissions in door-to-door transport chains. All the ports in the consortium are interested in these 6 case studies. We have divided which port is going to do what in order to model specifically the conditions in that port, check the validity of those predictive models, and then be able to expand to all those other ports that will be interested, whilst minimizing the resources that are needed. So in case study 1, the case study is going to be piloted in Valencia. We have already installed new sensors and equipment like speed and tail meter measurement cameras, environmental emission sensors on LNG and diesel trucks and vans. And we have also connected port existing cameras and sensors to the port environmental platform. There are also pre-existing systems like the track database and information coming from our port community system concerning the customs database and the terminal operating systems of the different terminals that give us crucial information about the trucks that are going to enter and leave the port in function of the needs of the different vessels that are going to call at the port in the following days. All this information is being an input for the port environmental platform, and the results are going to be predictions on how many trucks per hour will leave and enter the port in the next 24 hours and in the next 48 hours, and mitigating congestions. All this information is going to allow the Port Authority to mitigate congestion and the levels of pollution and accidents that are caused by congestion. In case study 2, sorry, this has gone. Okay. In case study 2, the pilot is going to be done in Venice, and they have also implemented new sensors. So they have extended their sensor network by including wind direction and intensity sensors in the Lido Inlet and Terminal, wave, tidal, and current sensors in Malamocco-Marghera Canal are also being connected to the port environmental platform, and new visibility cameras in Chioggia and the Lido Inlet. They are also connecting to the Italian Meteorological Center, and they are also obtaining information from their port community system. With all this data that is being processed by the port environmental platform, they are going to predict the closure of the Port of Venice due to tide, wind, or fog, and they are going to optimize the date and time of entry and departure of ships using predictive analytics. Case study 3, it's about improving air quality in ports and port neighboring areas. Here, this pilot is going to be done both in Piraeus and Valencia. In Valencia, we are testing a new camera that, using images, is able to measure real emissions from specific vessels. So we are monitoring the emissions that different vessels are generating in the Port of Valencia. Both in Valencia and in Piraeus, we are including also new sensors, like 2 new meteo cabins in Valencia, 7 sets of innovative sensors to measure air quality, 8 meteo sensors for temperature, pressure, and humidity in Piraeus, 2 air quality sensors in Piraeus, and 10 additional mobile sensors measuring different pollutants as well in Piraeus. So we have extended our sensor network and connected all this equipment to the port environmental platform. We are also connecting pre-existing systems like Port CDN in Valencia, Spanish and Greek meteorological information, and the information that we gather from the port community systems in Piraeus and Valencia. And the goal of this case study is to be able to predict air quality levels in a near future, so again, 24, 48 hours, and report to City Council and other governmental institutions. It is important to monitor and know the exact emissions of vessels if we want to create the right incentives for decarbonization, and also, if necessary, penalties for those vessels that do not meet regulation. In the case of case study 4, it's about reducing noise. Again, we've improved the sensor network with 3 noise measurement cabins in Valencia and 6 noise sensors in Piraeus, and we have also connected pre-existing systems like port CDM, SCADA, Greek and Spanish meteorological information, the information that comes from our port community systems, and our goal is to measure and predict noise generated by vessels at specific berths and how this is going to affect our port neighboring areas. The final goal is to reduce noise emitted by major sources via incentives to shipping companies and terminals. Case study 5 is going to be piloted in Germany. In the case of the German ports, they are already gathering information from third-party sensor networks. They didn't need to extend the existing networks, but they have connected to Windfinder, MeteoBlue, DWD, so existing meteorological and very specific parameters, sensors are being connected to the port environmental platform. They are also connecting pre-existing systems like the port CDM, German meteorological info, and all the information that DBH has as manager of their port community system. And they are going to estimate how ship-to-shore crane productivity is affected by wave agitation and currents. Again, the ultimate goal is to send warnings on expected reductions on port productivity up to 48 hours prior to the occurrence of the event, and inform vessels that were planning to call the ports, terminal operators, and other users about this fact so that they can plan ahead and adapt. Case study 6. It's about measuring door-to-door emissions in a multimodal transport chain. In this case, there are several partners involved. One of them is Balearia. Balearia has improved the sensors in 5 of their vessels, and they have also installed continuous emission monitoring systems, SEMS, in 5 vessels. Then we have also the 7 air quality sensors that we have installed in the Port of Valencia, and Gas2Move has also installed continuous emission monitoring systems in 3 trucks and vans. All this new sensor network is integrated with the Port environmental platform. And we are also integrating pre-existing systems like Port CDM, the track database in Valencia, and our Port community system. With all this information, we are estimating emissions of a series of goods from the time they are loaded in the warehouse of origin to the time they are unloaded in the warehouse of destination. And we can also compare different multimodal transport chains so that shippers, exporters, importers, where in this case we're talking about traders within Spain, can select the modes of transport that integrate their door-to-door intermodal chain according to the lowest environmental impact and the greatest efficiency. In activity 4, we are doing the coordination of the project, and also it's very important to communicate and disseminate the results of this project, because we believe that these case studies and the kind of results we can obtain are of interest for most of the European port system. We already organized an online event last year where we showed how we were working implementing environmental sensor networks and how we had developed the IT platform engineering. In this event, we are showing the results of activity 1, and there are upcoming events in Bremen, Venice, and the final event in Valencia. In Bremen, we are going to show the results of activity 2, big data modeling and advanced predictive analytics applied to the 6 case studies that we just reviewed. In Venice, we are going to focus on activity 3, so how we are reporting modules to external and internal users, and we also want to receive the feedback from the users and see how useful the information that we are sending and the models that we are estimating is for them. And finally, the final results of all the project will be communicated in a final event in Valencia at the end of the project. So this is all from me. Thank you very much for your attention, and we are ready to reply to any question, need for clarification that you may have. Thank you very much.
Thank you very much, Eva. Indeed, a very promising project. I will now proceed to our next speaker. I introduce the technical coordinator of Green Seaports project, Mr. Joan Messager, from Valencia Port Foundation. Joan was meant to be with us today. However, he's got the COVID, so he was unlucky. He will be joining us online. He will present the overall objectives of Activity 1 concerning the development of the environmental network and the Internet of Things platform. Joan, can you hear us? Joan has, he's an expert in artificial intelligence and Internet of Things, and has a background in telecommunications.
Thank you, Anna, for the introduction. Can you hear me well?
We can hear you, but we can't see you. Hang on a minute. Okay, great. Thank you. Hello, Jan. Welcome.
Hello, thank you. Good morning to all. I'm going to share the screen. I think you can see it now, yes? Okay. So, as mentioned by Anna, I will give the presentation, an overall view of the Activity 1, as is the main topic of this event, and the following presentations. I will focus on the main topic of today, Activity 1, but the main results will be explained throughout the case studies presentations after this one. So I will start with the objectives and tasks of Activity 1, and then we will go through the work done since the beginning of the project, which includes the development, the definition of requirements for the development of the PEP platform and the installation of the sensors, then the actual installation of sensors and the implementation of the PEP platform, and finally, the development of the validation plan that includes the definition of test cases and KPIs. Okay, so Activity 1 can be seen as the Internet of Things part of Green Seaports project, as its main objective is to install the sensors that will enhance the existing network of sensors in the core ports mentioned before, and also the development of the port environmental and performance platform that allow us to gather this data from sensors and other existing platforms or data sources. So that will give valuable environmental data from the ports that allow us to, let's say, develop the AI algorithms in Activity 2, and reporting the information regarding the impact of port operations in terms of environment to the end users. So, as mentioned, we will upgrade the existing network of sensors in the ports of Valencia, Venice, and Piraeus, and we will actually develop the PEP platform in the ports of Bremerhaven, Wilhelmshaven, Valencia, Venice, and Piraeus. As I say, this prepares us for the Activity 2, which is currently ongoing and involves mainly the development of the analytics and big data processing. So the Activity 1 is composed of 6 tasks and 5 milestones, which follows, let's say, the typical structure of an ICT project, right? So it starts from the definition of requirements, IT requirements. Then we proceed with the installation of sensors following the requirements defined before. And then in parallel, we also implement the port environmental and performance platform. Of course, we need to integrate the sensors with the PEP platform. So this is done in Task 4. And then we define the validation plan so that finally we can check that the data is properly sent to the PET platform and stored. So first of all, as in many other ICT projects, we couldn't kick off the technical part without defining the basis of the project. I mean, the requirements, right? So in order to extract the fundamental requirements of the system, we conducted a series of interviews with several stakeholders, like end users, technology providers, and suppliers. Then these interviews results on a set of requirements that we're collecting using a common template that you can see on the right side of the screen. This collection of requirements were done using a methodology based on the approaches of Bolere and Moscow, where Bolere allows us to classify the requirements into functional and non-functional requirements, and also into specific categories like performance, usability, look and feel, etc. Then in terms of Moscow approach, we are able to classify the requirements into priorities, right? So must have, won't have, could have, and should have. So in order to have some numbers of the requirements gathered, we can see this slide where a total of 55 requirements have been identified. 77% of them were must have, very important. And you can see also the distribution of these requirements among the different affected modules, okay, of the whole solution. So you can see this is concentrated into in both sensor networks and the port environmental platform. This is normal because this acts as the basis for development of the whole project, especially the activity 2 and activity 3. There are 5 main groups of requirements that concentrates most of these requirements, which are the operational type, performance, functionality, interoperability, and architecture. So going deeper into the installation of the sensors within the scope of activity 1, we built the required environmental sensor network to fit the prediction models that are being developed currently in activity 2, and this task, the installation of sensors, involves previously a process of tendering, right? So it's a long process because it includes not only writing the tenders, but also evaluating them, and also making, first of all, a benchmark of available technologies. Then the actual installation of sensor follows, and it includes not only the physical work on place, but also the configuration of those sensors and providing the connectivity, the telecommunication connectivity between the sensors and the PET platform. And again, here we used, in order to document the work done here, we used a common template that grabs the main specifications of the sensors and equipment installed under the scope of activity 1 in this task. So, as mentioned before, the Greasy Porch project has a strong Internet of Things component, which starts with the installation of 69 sensors to measure port environmental related data. In this slide, you can see a summary of all these sensors that has been installed in each of the 4 or 5 ports, and you will see them in more detail along the 6 case studies that we will present today. You can see from environmental control stations, remote gas monitoring cameras, wind sensors, tidal sensors, and and many others. Then, in parallel to the installation of sensors, the development of the platform started, and the main objective is to develop an IoT platform with big data and artificial intelligence capabilities that allows us to collect the data from the sensors installed, but also from other systems, like mentioned by Eva before, like the port community system or the terminal operating system. This allows us to have as much data as possible in order to develop the analytics and the machine learning models to alert or inform, report the end users with the impacts in a future basis. Here, I would like to emphasize that in this activity, what we did is to develop, define rather a reference architecture for the whole Green Seaports project. However, this reference architecture has been implemented locally by each port in a different manner. So the common point here is the reference architecture, but the different ports has been implemented accordingly to their needs, but following the reference architecture. So how we did it? So the starting point was the requirements identified at the beginning. We filtered them, getting only the ones related to the port environmental and performance platform. Then we classify them into functional layers. We extract from the definition of these requirements the functional modules or the functionalities that are embedded inside, and then we, let's say, form a kind of blocks, functional blocks, specific for each layer, and we linked them, connected them, forming the reference architecture. The methodology then, the next steps in this methodology was to apply a benchmark of available technologies to check, of course, not to reinvent the wheel, obviously, and to reuse or use open source or commercial products that allows us to actually implement the PEP platform that we need for our studies. So you can see here a high-level description of this reference architecture. And in activity 1, we focus mainly on the highlighted blocks that you can see in the slide. So starting from the bottom, we have the connectors and interfaces. This block consists of a set of connectors that read and receive information from the environmental sensor network. The connector shall translate the data from the origin data format into a specific format predefined by the data models registered in the data models registry that you can see on the left side. Finally, the connector shall inject the data into the data ingest block, which is the data streaming mechanism, which usually performed by a scalable, distributed, and partitioned log system. It is storage in real time. It is storing real-time data coming from the Green Seaports installed sensors and existing systems. Then we have the storage, data storage, which is actually the cold storage of post-processed data, reports, analysis, and predictions made by the models. And this data can be used by the batch processing block that allows us to take the final data to exchange it to the other platforms or to the end users. And finally, we have developed in our PEP platforms the port peer-to-peer interoperability functionality, which PEP platform may interact with other third-party platforms, for instance, in case study 6, as you will see, to get data from vessels from Balearia or the funds from Castumor. Then we have the vertical functionality blocks, like traceability and logging. This functional block monitors the platform's usage by the users, devices, and producing an audit log with trace of changes made and maintaining the log records, etc. And then we have the security layer, which applies security, authentication, authorization, and decryption along all the layers of the reference architecture. So in activity 2, within the scope of activity 2 and 3, the rest of the models are currently implemented. These modules concentrate the functionalities related to modeling, reporting, and visualization. So as I said before, the previous reference architecture was used as the basis to implement the various PEP platforms for each port. In each case, a combination of different technologies and tools were used. Some of them were open source and some commercial solutions. As you will see in the next presentations, for each case study, you will see in detail how these PEP platforms were developed and which are the actual tools used within them. And last but not least, one of the tasks performed here in this activity is the definition of the validation plan. In the same way, like in requirements, this validation plan, of course, is based on definition of test cases and KPIs that will allow us to validate the different developments carried out in the activity 1, 2, and 3. As in the same way, like in requirements, we also use templates, common templates for the collection of test cases and KPIs. In case of test cases, they included a stepwise description for their execution, later execution in the last task of this activity. KPIs also were classified into categories and fields. As you can see here, the main three dimensions were impact and exploitation, case studies, and ethical, societal, gender, and legal evaluation. Here you can see an example of one KPI that we have defined in the scope of the project. So, at the end, we have defined 28 test cases and a total of 52 KPIs. You can see them distributed among the different categories. And as you can see here, in terms of test cases, most of them are concentrated in the case studies 3, 4, and 5, as they also involve several ports at the same time. Then, if we look at the results, we'll see more in detail in the next presentations, but as an overall view, a total of 13 test cases have been successfully executed in this activity, and a total of KPIs were already addressed in this activity. You can see that you can see them in this screen and in this table, and especially to mention that some of these values achieved go beyond the target value predefined. Most of these KPIs were obviously concentrated into the installation of sensors, as is the main topic of this activity. Okay, so that is all for activity 1 general description. And as I said, you will see more in detail what has been done in each port in case studies presentation. Thank you.
Thank you very much, Johan. I will stick to you to go to the next presentation for case study 1. So please enlighten us on how to decrease the port congestion, the port traffic congestion at the port of Valencia. Thank you. The floor is yours again.
Thank you, Anna. So I will follow with this case study, the first case study. Let me change the presentation. Okay. So I will present now case study 1, decreasing port traffic congestion at the Port of Valencia. I will start from the case study 1 description, looking at the objectives. Then we take a look to the sensors and the equipment installed to achieve the objectives in this case study. And we finally go through the PEP platform of the Port of Valencia and the integration work with the main sensors used in this case study. We will finalize this presentation with a demonstration of how this data is being received in the PEP platform of the Port of Valencia. Well, as you can imagine, the increase of international trade and the arrival of larger container ships is causing significant levels of congestion in peak traffic times at maritime ports and terminals. The more number of trucks are inside the port, the higher number of pollutants are emitted, obviously. So this may affect, of course, affects to the surrounding areas, including local population. So the way we would like to avoid this or minimize the impact is to develop an AI tool, which we don't have at the moment, that is able to predict the number of trucks that will arrive to the port in short term or medium term. This will allow us also to develop a reporting tool that will alert the port managers about potential congestion events, so that smart decisions can be taken in order to minimize the impact or avoid these events. So how we are going to do this? Well, we started by the installation of 8 innovative cameras that are able to measure the traffic congestion in certain or in critical points of the port, especially at the entrance of the port and the terminals, and also in those points where some potential bottlenecks can occur. So apart from this, the installation of these cameras, we develop, of course, predictive models able to predict the number of trucks that will arrive to the port, but also the congestion events on these critical points. Then, by applying, thanks to this development, as we are developed or we are going to develop these models, we will be able to apply some kind of simulations in order to see which is the impact of applying some certain actions. And then we will analyze how this congestion can be reduced and which are and how the CO2 emissions are reduced, of course, in consequence of reducing the congestion. Finally, the reporting modules will be developed as well in order to report the port managers about potential events, congestion events in future. All right, so in this screen, in this slide, you will see the general concept of the case study 1, and starting from the main data sources that we are using in this case study, from the automatic gate systems that allow us to get data from throughput data of the port in terms of number of tracks. And we are using the air quality sensors to see the environmental impact of the road traffic. We also use port community system to get data of future port calls. And last but not least, the congestion cameras that we use to measure the congestion levels in these 8 points in the port. All this data is sent to the PEP platform to telecommunication connectivity, and then finally this data is used by the predictions and analytics to inform the end users about potential future congestion problems. So the main equipment used in this case study, as I said, is the 8 AI cameras that are able to detect objects, mainly, of course, trucks in roads. They are able to detect also the level of objects inside this area monitored and the objects that are crossing a certain line in the area monitored. So then, thanks to the Genetec traffic sensority system, we are able to apply artificial intelligence to actually get the final data that we use for the AI models that will predict the congestion level in a future basis. This data is speed, direction, travel time, and the number of tracks and level of occupancy in the area monitored. Then we have the 7 air quality sensors, as I said, that we are able to allow us to gather environmental pollutants like the sulfur dioxide or nitrogen monoxide, etc., and the particles. On the right side, you can see the actual location of the 8 cameras in yellow, in blue, and then in green you have the location of the 7 air quality sensors. You can see the Genetec system, which allows us to see how the cameras are detecting the objects, the trucks. The system allows us to configure some parameters of cameras, like thresholds of number of tracks. And now in this slide, I would like to introduce the actual platform of the Port of Valencia. Well, in big infrastructures like in commercial ports where several system devices and sensors are deployed, need a powerful tool which allows them to store big amounts of data in a fast way. So the baseline tool being used in the Port of Valencia is the PI software from Osisoft, which is also being used in other heavy industrial environments like, for instance, power plants. PI system is a suite of software products that are used for data collection, historizing, finding, analyzing, delivering, and visualization. Data can be automatically collected from many sources from the PI interface and the connectors. This P connector sends the data to the PI data hive, which collects, stores, and organizes data from data sources. And the definition of representation of the organizational assets and the creation of digital twins are performed by the asset connector. Then we have the dashboards the PI visualization suite that allow us to create dashboards and reports to the end users. And finally, we have the PI integrators that allow us to prepare and send time series data to the third-party analytics platform. So this is the actual implementation of the PI system. And as you can see here, PI interface component is deployed in a specific server in the industrial network, as most of the data sensors or as most of the data sources come from this network. Then we have three components here. We have the P data hive. Here we have the P asset framework and the PI vision, which are in the corporate network, where the data will be analyzed and explored. Apart from that, we have an additional server where REST API, integrations with third-party cloud platforms or cloud platforms are managed. So this is the modules that are used in this case study, the ones that are highlighted. And now we are going to see how the specific integration for each of these equipment. So regarding to the traffic monitoring cameras, the cameras send data through fiber optical to Genetec platform, which provides the AI mechanisms to count the vehicles and it gives occupancy levels. Then this video management system has integrated a OPC UA server, which allows us to send the data to PI, their data hive, through the OPC client. So this is the OPC protocol. And here you have an image of the OPC connector that allows to send finally these three parameters, which are the number of vehicles, the speed, and the congestion levels. Then, regarding to the automatic gate systems, all sensors deployed in this port south access, entry and exit, are connected through PLCs, which sends the data through fiber optic to the SCADA system. In the SCADA system, then we have, again, another OPC connector that sends a OPC server on the SCADA side and an OPC client on the PI or PEP platform side, and data flows between these two connectors in real time. And basically, data transfer from these automatic gate system sensors are radiation alarm, barrier open, the gauge to discriminate, to differentiate between trucks and vehicles, light vehicles, etc. Then we have also integrated air quality sensors in a different way, like the two previous ones. In this case, air quality sensors provided by Inerco, installed by Inerco in the Port of Valencia, are sending data to their cloud platform to 4G connectivity. And then in this cloud platform provided by Inerco, the validation and final tuning of the data is done. And we have there we have a HTTP connector that publishes data in real time, gathered from the sensors, to our middleware. We have a middleware implemented also in the infrastructure of the PI system, where translates the data in the format of the sensors to the format that is necessary in the PI system. In this last part, we use HTTP REST protocol. Here you have an image of how it looks inside the middleware. This is done by an Node-RED tool, which basically allows us to create functional blocks that with a specific function to make this grab and publish to P platform and making this message translation. And here I will show to you a video or demonstration where you can see how this data that we were mentioning before are being collected in the web platform and how this can be visualized in our platform. So here we have created several dashboards, and the one for the case study is this one. And you can see here at the top the actual location of the sensors. Here you can see only six of these cameras, because 2 of them are under maintenance. But you can see here in real time some parameters they are giving. For instance, the congestion levels in kind of traffic light basis, so green, yellow, and red. This gives us the level of congestion in these points, and also we can see here the real-time values of the number of trucks detected in this moment. Here we have also the way we did it is using velocity gauge, just to see which are the maximum number of trucks that are good or are under let's say congestion level. Then we have here a time series chart where you can see the number of trucks that are being counted along the day for each of the lanes at the south axis of the port. And here you can select one of the lanes and some, let's say, line in time to see the actual values for each lane. Here we have also a table where the main events from the south axis are being collected, and you can see here the actual let's say events, which mainly basically means the trucks that are going across these gates. And here we have also added the weather data, which can be also used as a kind of correlation with previous charts in order to see how some meteorological data can affect the number of trucks that are entering and the number of the throughput of trucks within the port. And as I say, this dashboard has been created within the PI system using the PI vision tool. And that's all for the case study 1. Thank you.
Thank you so much, Johan. I suppose you won't be feeling better after 2 presentations. So sorry.
Sorry for that. But I
so sorry.
Some
no, you were great.
symptoms.
Thank you. So before going on to the next case study 2, I would like to inform the online participants that there is a chat available under the YouTube channel. So if you would like to submit your questions or comments on view on the subject, feel free to do so. So I'm continuing to case study 2, improving maritime accessibility to ports. Although we do have Mr. Paolo Menegaso here, who is the head of unit of strategic planning and development of the North Adriatic Seaport Authority, he will be available to cover all technical content and questions. However, the presentation will be done on his behalf by Cecilia Volpato. Cecilia is part of the team of the strategic planning and development at the Port of Venice. She has been running for more than 20 years now numerous R&D projects. She's responsible for the management and for the monitoring of the technical implementation. Cecilia, the floor is yours. Thank you. Yes, or this.
Okay, thank you.
Whatever suits you.
Hello to everyone. Good afternoon. Thank you, Anna, for introducing me, and thank you to everyone who has contributed to the organization of this workshop. As Anna said, case study 2 for Venice deals with maritime accessibility. And I'm going to give you a brief overview of how the situation is where we found ourselves in Venice, how the Green Seaport projects fit in it all, the level of achievement we have already achieved, and in terms of sensors up and running and integration with the PEP platform. I will also explain briefly what we are doing right now. We are moving from using real-time data to managing them to develop forecasting models. And the last very important goals we have in mind, which is the realization of scheduling tools for traffic planning and strategic planning. The city of Venice, the Port of Venice and the Port of Chioggia lays inside a lagoon, which is a very delicate environment. From one hand, the lagoon acts as a protection for the navigation. But from the other end, it's a reason of complexity for port operation. Someone before, during the coffee break, someone which is here in this room, asked me about the tide in Venice. How these high tides affect the population. And this is a picture on how the situation is currently in Venice. The high tide indeed affects population. It's an overwhelming situation for the population living in Venice. This is why the government realized the Moses system, which is a system that works with barriers that are risen in case of high tide. With this system, the city doesn't have the risk anymore to have floods, water flooding in the city. But on the other hand, it means the closure of the port with all the consequences of this fact. It is essential for the Port Authority to know beforehand when this occurrence will happen, when the tides will be high and when the ports will be closed. The closure of the port is influenced by weather condition and wind. The entrance to the Port of Venice is guaranteed through a channel, the Malamocco-Marghera channel, as every port channel has the needs to be maintained, continuously maintained. This is why we have started this project, Channeling the Green Deal for Venice. It's a CEF project co-financed by European funds. It has the objective to reach, through a very innovative approach, the design of an infrastructural solution to have a long-lasting way of maintaining the canal. Long-lasting and less as possible environmental impact, It is innovative because it combines navigability simulation, hydrodynamic simulations, infrastructure and management alternatives. It has been awarded, it is a study ongoing, it has been awarded to a consortium of enterprises led by the Danish Hydraulic Institute, DHI. So the accessibility, maritime accessibility, is a problem that can be solved with infrastructure solution, like the channeling from Green Deal project I was talking to you about, but also with a management solution, like system for traffic optimization, information sharing, and navigational aids. And this is how the Green Seaports fits into this situation. So maritime accessibility for us is like a wall. It has to be built with bricks. Bricks by bricks, we built maritime accessibility. So here you have an example what these bricks are. We are new port cartography that has been upgraded with the DIGLOC project, is another European project. Sensors network up and running with Green Seaports project. Framework agreements, weather forecast data, data exchange in MOSE operation, the MOSE system I was talking to you about, again, thanks to the Green Sea project. All these bricks will bring us to the most complex and most relevant output, which is a just-in-time concept, which is a concept right now, but hopefully it will be a project. It's under evaluation right now by the CINEA and is led again by the Valencia Port Foundation. So the bricks of the Green Seaport projects have the objective to improve the port performance, the strategy to improve scheduling of ships' arrival and departure slot. The tool will be the optimization of ship traffic based also on weather condition and real-time forecast. The requirements are meteo stations, real-time data sharing, and weather forecast. This is where we are right now. Sensors are up and running, and they are already integrated in the platform. We have placed 4 visibility sensors, 3 wind sensors, 5 cameras, sorry. All civil works and equipment necessary are up and running. Everything is in place and is working. This is an example of where the sensor have been placed. This is called MEDA, it's a Venetian name, and the MEDAs are placed along the canal where the places where they are necessary and they are available. This is an example how the wind sensor displays its data sharing. I'm not going into detail. If you have any question, you can ask later. And this is an example how the cameras works. And the cameras have dual purposes. And for one side, they state the situation. You can see how the canal is. But from the other side, they also act as a validation of the other meteo data. For instance, in case of fog, because the fog can have a boundary which the camera detects, but the fog sensor doesn't. And so now we go to the PEPS platform, which is working already. And it integrates and manages all data coming from the sensors, not just the sensor of the Port Authority, but also the one put in place by the Venice municipality. They are managed, the Venice municipality manages the sensor with their scopes, but the data are also sent to the National Coast Guard for other scopes, such as the managing of vessels traffic. And in our case, we have realized an application, a web application, It is called the Porto. It's free of charge. You can open it and use it. It's very easy. And whenever you open it, like I'm doing it right now for you, you can see exactly the canal in the port of Venice, the city of Venice actually. If you click on the icon, you can see where the sensors are and what the sensors are showing in real time. You can detect any other vessels or boats which is navigating. So it's a very easy but useful instrument for the safety of navigation. It has been downloaded for about 1,000 of people already, and it was realized with the Green Sea Port, so this is already working. Here are other images of how it works. Clicking on the icon, you will see how the sensor works, what they are displaying in this moment, how the situation is. And now we are moving ahead. So we are managing right now real-time data for the situation as it is now. But we need to move it ahead and use real-time data for forecasting, data forecasting. So we are about to start studies that will deal with the connection, the tide and surge storm forecast for MOSE activation. So see when the MOSE will rise barriers. We will connect with forecast with the municipality, again, for the connection. And we will start an innovative study to forecast the occurrence of fog. It's very innovative, it has never done before, so we see what we can achieve, and we hope we can achieve a good result for our port and for the Green Sea projects. The last but not least tool, which is very relevant for us, is a scheduling tool for traffic and strategic planning. Again, this is a quite complicated scheme. I don't know if I'm able to explain you anyhow. I'll try. The port infrastructure are represented in the rows in the bottom of the scheme, are the berth, the single berth that the ships needs to reach. The line that goes vertically are the ships, and the extension in longitudinal dimension means the time they take from navigating from the inlet to the berth. So this is a scheme that represents how the infrastructure is. Inside the infrastructure, which cannot be moved, of course, we need to put and play with all the other occurrence, MOSE barrier, wind, any other occurrence that we cannot control, but we need to try to forecast. In this way, we will be able to manage the traffic and to plan the traffic, but also to plan other further strategic investment, strategic improvement in our port. The case study I'm showing you now represents how the management of tugboats could have been better used, better managed, in case we had this model of prediction of fog. The scheme on your left, represents a period in where the port was closed, the 21st of February, due to fog. And if we had known beforehand that the port would have been closed, instead of using 11 tugboats that were the one used when the port was open again, all the ships were eager to go ahead, move in or move out. So 11 tugboats have been used, have been requested. If we had known in advance the fog was coming, we could have used only 9 tugboats. The 2 tugboats are money saved and are more port efficient. And this is all from my side. If you have any question, Paolo and me are very happy to help with you with it. Thank you.
Thank you very much, Cecilia. Proceeding to our next case study 3, I would like to invite 3 speakers, Mrs. Katerina Kadena, Mrs. Katerina Georgiou, and Mr. Mark Tanner, to present on how to improve air quality in ports and neighboring areas. Mrs. Katerina Kadena and Mrs. Katerina Georgiou are from ICCS. Mrs. Kadena is a chemical engineer. She has been a manager in R&D projects for many years, dealing with various categories: resilient systems, IoT, environment, security, etc. Katerina Georgiou is an electrical and computer engineer. She specializes in robotics, in simulations and 2D mappings. Mark Tanner is joining us online. He's from Valencia Port Foundation. He is the R&D project engineer of the foundation. So I welcome all 3, and I call Katerina Kadena to take the floor and start the presentation.
Hello, everyone. Welcome.
Okay.
So, yeah, I know. Height issues. Thank you. Welcome, everybody. It's a real pleasure to have you all here today. We have been trying to work together in this Green Support project, and here today I'm representing the whole Greek team and the work that has been done in Piraeus. So I will try to skip the numbers here, since already Johan and Eva have mentioned them, but the decarbonization and the emissions monitoring and the whole sustainable development goal of the European Union does not go alone, and there is also the operational efficiency increase out there, and the new business development, and the money that we need to generate from whatever we have to reduce, we have to increase the other, let's say, leg of the whole things in the maritime economy. So I will stay a little bit on the Zero Pollution Action Plan about air, water, and soil, which actually urges us to receive better monitoring of air pollution, meaning that we have to receive data that can be interpretable, so that it can be used to help us make better decisions and informed decisions. So having said that, and taking into consideration that the port infrastructure position and location has an integral influence to coastal territories, and the operations have an impact to the overall environmental quality of the neighboring areas, and of course the local authorities and port management need quick and accurate information in order to move forward and take mitigation actions. The whole idea behind Green Supports was this PEP platform, which allows for smart and flexible monitoring and visualization of data, so that those that they need this information can take better decisions, informed decisions, and of course, at some point they will be able to have predictions for the air quality levels in times and space. So what we have done here in Greece is that we have been working with Port of Piraeus, the municipality of Piraeus, and Zen Travel and Glomar, which they have installed mobile and fixed sensors and also meteorological stations to measure temperature, atmospheric pressures and humidity, and sensors to measure air quality, both fixed and mobile. So you will see here the several applications in the port and in the city area, and of course in the trucks and buses. So going a little bit in more detail, we have installed 3 sensors, 3 set of sensors to measure meteorological data, and also the municipality has installed 2 additional set of meteorological sensors. We have installed 7 sensors to measure air quality, and these measure mostly NOxes, so dioxide, nitrogen dioxide, carbon monoxide, sulfur dioxide, and particle matters, PM2.5 and 10. We have also installed 2 sensors to measure noise level, but that case will be explained to you after the lunch break. And also municipality has installed 2 additional set of air quality sensors in the city. And finally, 8 additional mobile sensors, 2 are under construction, under the fixing it anyway. So they're also measuring these emissions and also ozone. So here you see how they have been distributed in the port area and a picture of the installation. Here again are a little bit more detailed, the whole parameters that we're measuring at the moment. At the port area, we have installed 3 stations, so 1 at the entrance of the port. They have been installed by Purcon. And the second station is at the cruise terminal, and the third station at the container terminal. So there is a video here that you can see from the installation process. Thank you. So same thing has been installed in the municipality areas, and they're located at the rooftops of 2 different buildings. So you will see that they're distributed somehow in the municipality area, just to assure that we don't receive overlapping data. So here you can see also the pictures of the 2 stations that have been installed, and a small video. Sorry for that. From the installation of the municipality. No music here. I'm muting it because you never know what a Greek guy may say, so it's like it's better if you you don't hear anything. Okay. So here are the mobile sensors. They're supported by GPS and 4G connectivity, and of course from photovoltaic panels for low power consumption and increased autonomy. You will see the installations that took place on the trucks and on the buses. no picture of me on the buses, but I can show that to you. So the overall point of what we have done here is that a must-have for everything that we do is in the port area and in the neighboring areas, is that we create this common operational picture, common operational view, so that everybody can see and can receive visualized information. So all data coming from the fixed sensors from the port and the city, and the data collected from the vehicles, they're all combined to build this operational view and further driving intelligence to decisions. So a little bit more technical description here. So the PEP platform collects the data from both the fixed and mobile sources, and then we use an API integration to feed the data into the data collected from the nodes into the PEP platform. So upon integration, they're consolidated to data sets, to data analytics is performed and demonstrated through visualization. And there is a user interface component with overlaying dashboards and other representations for the responsive devices. So you can both see them in your mobile and tablets besides your laptops. So that the end user can explore from everywhere and real time what is going on in the port area in the neighboring areas. So the same concept is applied for the extraction of reports and reporting of data. Here there is a small visualization of what I just said. So we have these 4 data sources. They're fed in the PEP platform through 4G and DSL, and then we are going to apply the predictions and the AI in order to receive these decisions from the users. So a small representation of the overall architecture we have tried to simplify it as much as possible for the audience to understand what has been done. So we have the sensors, the Symmetron cloud platform, and the Arequal cloud platform for the air quality sensors. 4 data sources. They're fed in the data integration layer of the platform, and then we have 2 supportive layers, one with the predictive engine that is currently developed, and then the data visualization layer that you will see. So as Johan explained before, we have used a meta-architecture approach here to assure for agnostic, let's say, integration, and assure that this solution will be interoperable and can be integrated with any other legacy system without further development needs. So I'm going to skip this because it's already there for you. As you see, we have the several IoT devices. So there's the sensors and the stations there, and through an adapter, they're fed in the Piraeus PEP platform. And the predictive engine at the moment is developed so that here the end users, they're going to receive what we have developed here, a tested and validated platform, which my colleague Katerina Georgiou will demonstrate to you in a couple of seconds. So, yeah. Floor is yours.
Okay, hello everyone. So for the integration of the PEP platform, through Piraeus PEP platform user interface, the end user is enabled to explore the data and gain in real time a clear overview of the time source of environmental phenomena of interest at a glance. Through the user-friendly interfaces, the user is able to visually inspect the observations filtered by the observed phenomenon and device, and export user-specified data in a CSV format. The platform is capable of sending additional alarms to the user when the sensors pick values that exceed the maximum allowed. So this is some screenshots of the PEP platform. As you can see in the menu there, this is the content list. The things that we are most interested in is the devices and the dashboards. Also we can see assets and entity views. The user can see can click on the devices, and there's a download button that they can export the data in a CSV format. Also, there's the dashboard, as I said. We have created 1 dashboard per device. and the representation of each sensor is given to a different graph. And also we have air quality color segmentation for better to be better for the user to understand the quality levels of the air. This is a screenshot of this is a list of the devices that the end user can see. This is the fixed devices that are in the Port of Piraeus and the municipality. And this is the list of the mobile sensors. This is a screenshot from a dashboard of the device. In every graph we can see every sensor, how it is presented. And so for the air quality, we see two screenshots, one from a mobile device and the other one is from the port. As you can see, there's a segmentation that characterizes the quality of the air with colors as good, fair, moderate, etc. And now we can see a video of the platform. Okay. When it starts. So logging in the web application, the user, by clicking the devices, they see all the devices that are available to access. And by clicking on every device, there's a download button, as we said before, that the user can select which sensors of every device they want to download the data. They have to select the date range for the data they want to download. And here you can see that there's a timestamp at every measure of every sensor. And in the dashboards, for every device, there's a dashboard that shows every graph of every sensor. The user has the ability to click on every graph and see in detail the measurements, the data. They have the ability to see the real-time data or even historical data. And select which dashboard they want from the user interface they want to see. Okay, that's all for me. Thank you very much.
Thank you. Mark, are you there? We now have to pass to what?
Yes, I'm here.
Okay, great. So Mark is going to present the same case study, but for Valencia Port. So will you be changing the slides, or would you like me to do it for you?
No, if you could do it for me, please.
Okay, great. Okay. Can you see the slides?
No, not at the moment. Yes.
Αυτό που παίζουμε, το ίδιο είναι. Ο ίδιος δεν το βλέπει.
Yeah, I can see them.
Okay, great.
Well, thank you very much. Hi, everybody. As just been said, I'm going to go through the case study 3, which is also here in Valencia as case study 1, and it focuses on improving air quality in ports and port neighboring areas. Okay, so next slide. Next slide is I'm going to go through the general concept. Okay, so basically there are two main motivations. One is for ships to comply environmental regulations when calling at EU ports. This, for instance, requires individual ship monitoring. And then two is being able to quantify and control air quality towards neighboring areas. The Port of Valencia, to be precise, has two neighboring areas right next to the port. But the main problem is that ports lack of the high-tech equipment to be able to monitor each vessel and provide consistent and reliable reports. Okay, so in case study 3, we'll integrate different systems and sensors, which I'll explain in the next slides, to be able to send specific data and information to the PET platform to then be able to quantify and also predict ship emissions. Okay, next slide, please. Thank you. Okay, so the measurements and data are provided by two types of sensors, which have all been strategically positioned in the port area. These are meteorological and air quality sensors. We also use a multispectral camera, extremely innovative and high-tech, which allows us to measure individual ship emissions in real time. It's portable as well, so it's not fixed in a specific area. And then we have the port calls, ship AIS data, and also the ship's characteristics, which is all then combined and introduced or included into the PET platform. All this data and information as is included in the platform, which is the one in charge of processing it all. And this is done by two ways. One is through analysis based on artificial intelligence, and the other is through air quality predictive models. And what this allows us to do is to evaluate different actions in order to minimize the environmental impact of port operations with the city by simulating different scenarios based on, for example, wind, number of port calls, etc. So it's based basically according to the port needs. And then in relation to case study 6, we can also simulate the impact caused by different vessels using specific fuels. And this is together with the Balearia shipping company. Okay, next. Here we have a basic schema of how it works. So on the left, we have the sensors with an image, so you can see each one. You have the optical imaging camera, the multispectral imaging system, meteorological data, sensors, air quality sensors, and then on the bottom you can see we have the port community system, which is the PCS, the AIS data, and other information, which is the ship characteristics and so on. The info and data they gather is sent to the platform via FO, DSL, 4G networks. The data processing is performed within the PET platform, as already mentioned, and then it provides the predictions and the artificial intelligence-based analysis. So all this to provide reports and suggestions to users. And when I say users, I mean shippers, freight forwarders, shipping companies, sea carriers, city council, neighborhoods, and citizens. Okay. Next, please. Regarding the sensors and the equipment used in Valencia, we have strategically installed 2 meteorological cabins. These include analyzers and a data logger. And if you look here on the map, you can see that the 2 light blue pinpoints are where the cabins are located. They're also known as environmental emission control stations. Then we also have installed 7 sets of air quality sensors, which are the light green, and these are strategically positioned in areas such as entrances, exits, port city boundary areas to see the exact, to be able to quantify, the boundary between the port and the actual city. And then we have also as mentioned earlier, the optical imaging camera well, here you can see the different images for each one. Okay, next we have a brief video of the equipment and part of the setup. So next slide, please. Can you press play? Not sure if I can't see it.
Mark, I'm not sure that...
Does it work?
Not really.
Oh, okay, hang on.
Shall I move on?
Not sure.
Or you can show it from your side.
Hang on, let me see if I can get it. 1 second. Ooh. One second, sorry.
Mark, would you like to share your screen and show the video from your side?
Yes, that's what I'm trying to do. Sorry.
Okay, Dimitri, can we do that? Okay, thank you. Yes, Mark?
Yeah, okay. How do I share it on Zoom? I'm sorry, I'm not too familiar with how screen sharing is. Compartir pantalla, okay, 1 second. Can you see my screen?
Yes, we can. Yes, it's playing. Thank you, Mark.
Okay, so here it's the air quality sensor setup. It's got a solar plate, so you can see the operators here just installing them on the different poles or the different lighting through the port. As I said, there's 7. This is the meteorological and emissions cabin, which has the analyzers inside and the data logger. 2 of these are installed in the port. This provides connectivity to the PEP platform. And then we'll move on to the actual camera, portable, and so it can be, campaigns can be carried out through different areas of the port, and it's specific to be able to monitor individual ships coming in or leaving, or which are berthed and operating. The camera is connected to that little box that you can see there, which has a computer and it has internet connection. This is the interface of one of the actual cameras. As you can see, it's in black and white. Then it has different types of visualization, where it focuses on the different exhaust pipes and it detects the gases. This is the interface of the actual platform, which is the Red Dot service software. And that's basically how you would see it when you're looking on the computer. Okay, so I think that's it. Can you continue sharing your one?
Yes.
Yes, thank you.
Can you see it?
Yeah, I can. Okay. I can see it only in small there. Hang on. Okay, yeah. So we're back now to the sensor integration with the PEP platform. 1 second. Okay, so this slide represents the integration architecture of the 3 components. You can see the environmental cabins up on the top on the right, air quality sensors and the optical camera. And well, the different integration with the PI data archive, the assets framework, etc. And how also the other data, such as the port community system data, the AIS data, and so on, is also connected to the system. So it represents the different modules of the PEP platform which are involved in the sensors integration. So as in the case study 1, the raw data is finally stored in the PI data archive, which is the actual time series database of the Valencia Ports PEP platform. Okay. And now in the following 2 slides, we'll see how the environmental cabins and the optical camera are integrated with the platform. So it's going to be it's the architecture of the individual ones. So next slide. The environmental control station, the environmental cabins, has a data logger, as I said earlier, collecting the data from the sensors. From the data logger, the data is sent to the SCADA system through OPC protocol and to the IRIS application through an FTP protocol. From the IRIS application, the data is sent to the PEP platform interfaces using ODBC connector. Okay, and the data that it sends is, well, you can see it there, it's different gases, wind direction, speed, temperature, humidity, etc. And then here on the right is a screenshot of the PI assets framework where the cabin sensors are shown. Okay, very similar as well. Well, the next one actually. Next slide, please. So now it's the same for the optical camera. So from the camera, the data is sent using a HTTPS REST to a Node-RED middleware, which is a data processing platform, as Joanne mentioned earlier, in the port premises through 4G. The Node-RED middleware translates messages to PI format and sends them to the PEP platform. Okay. On the bottom here, you can see 2 screenshots. One on the left is the JSON message sent by the camera, and on the right is the Node-RED processing of the message to convert it into the PEP platform's format. Okay, and now to finalize, we have a video showing the assets framework of the PEP platform, which allows us to see the different signals coming from the sensors. Okay. Yes, you can. Can you play it? I don't think I have this one.
I'm playing it.
Oh, okay. Sorry, I can't see. Okay, great. Okay, so on the left, you can see the list of sensors and systems integrated in the platform. Through this interface, we can individually navigate through the different sensors. For example, the optical camera. Here we can see the list of parameters, timestamps, and the same for the other sensors, which is the air quality and the cabins. You can see the parameters and the timestamps there as well. It gives you a date and it gives you a time for each recording. There you can see the 7. There's one for each of the sensors. Now we'll navigate through the data archive in a minute. Sorry. Now we'll navigate through the data archive, which is the streaming database of the PEP platform. Here you can see the latest values for the signals that we saw previously. And this is the dashboard visualization part. Here we can see the values of the different signals as well. Meteorological parameters measured in one of the cabins in real time, and then historical plot of each of the environmental pollutants measured by the cabins, which is here on the bottom. The dashboard allows us to zoom into into the different graphs as well, so you can. Oh, sorry, it's okay. That's finished now. Yeah. So the graph, as with the others, you can stop that one now. That's the last of the video. It's playing again. Now, what I was saying to finish off is the graphs. They allow you to visualize the latest data, and it allows you to zoom in to be able to analyze different ways and so on. So thank you for that.
Thank you very much, Katerina, and Mark. A rich presentation, indeed. We have finished our 3 case studies out of 6. So before going to our lunch break, I will open the floor for discussion. Please share your questions with us, either physically or online. For any online questions, I will ask for the support of Dimitris at the IT, okay? Do we have any questions or comments on the presentations? Nothing? Perfect. So we're finishing really early. Okay. So we are going to proceed to our third and final session of the conference. It will present the 3 remaining case studies of the Green Seaports project, the overall status of the project and the next step, and some concluding remarks to conclude with the conference. So I will welcome our next speakers. We have Mr. Pablo Jimenez from the Valencia Port Foundation. He's going to present case study 4 on reducing noise in ports and neighboring areas. Along with Pablo, Mrs. Caterina Cadena and Mrs. Caterina Georgiou will be supporting him at the end of the presentation concerning the application of the case study in Piraeus as well. I don't know if we can, Pablo, can you hear us? Pablo is an IT manager. He is with Valencia Port Foundation. He deals with IoT, big data, cybersecurity. Pablo, can you hear us?
Yes, I can hear you.
Okay, thank you very much. You can share your screen if you want to, and you can start your presentation.
I'm sharing it, and you see it? Anna, can you see the
Yes,
slides?
I can see it. Yes,
okay.
Go ahead. Thank you.
So, good afternoon, everyone, and thank you, Anna, for the introduction. As she said, together with my colleagues from ICCS, Caterina Cadena and Caterina Georgiou, we are going to present you the case study 4 from Green Seaports about reducing the noise in ports and port neighborhood areas. Let me start with an introduction. Let me start with an introduction of the case study. Then we will show you the sensors and equipment installed in both ports, in Valencia and Piraeus. And then we will see how these sensors have been integrated with the PET platform. And we will see an examples of how we can visualize the data. So as a general introduction, all of you know that ports usually are integral part of cities. And you know also that in ports we have several noise sources, not only from vessels like cruise ships, container ships, and ferries, but also from railways, trucks, industries, and shipyards, and other sources of noise. All these activities have a strong impact in the surrounding areas, and not only for local population, also for marine ecosystems. The ports must comply with the EU Environmental Noise Directive, which provide a basis for measuring actions aimed to reduce the noise emitted by most of these kind of sources. As I said, we deployed, and we are going to demonstrate this case study in 2 different ports, in Valencia and Piraeus. In the case of Valencia, we have 2 neighborhoods close to the port facilities. So we have installed 3 new noise meters in order to measure the noise generated by vessels and other kind of operations. With all this data, we are going to generate noise models and calculate predictive models in order to know in advance which will be the level of noise and take some measures if needed. In the case of the Port of Piraeus, will be similar. They have installed four new sensors strategically to cover all the port and neighborhood activity. And similar to the previous one, the objective is to measure the noise generated by vessels, trains, trucks, and all operations in order to forecast the noise level 24 hours in advance. This is the general solution that you already have seen. We have on the left side the data sources, which are sending the data to the PEP platform from different channels and protocols. Then the data is available first for the end users in order to see the data through dashboards and reports, and also for prediction and AI-based tools. Let's move to the case of the Port of Valencia. You can see here in this picture the three new noise meters that we have installed. They are inside these cabins, and we have a pole in order to install the external microphone. And we have inside also the data loggers and all the communication equipment needed for sending the data. You can see here in the map also the locations. They are in the interface between the port and the city, because as I said, we have these two neighborhoods that are close to the port, and we want to measure the impact from the port. Here you can see the general architecture of the deployment in the Port of Valencia that you already see before. We have the noise meters that are sending the data to the SCADA systems, and we are using this system for maintenance purposes. And then the data is sent to the PEP platform. I'm not going to go into the details of the platform because you have seen it this morning with my colleague Joan. So I will explain a little bit more details about how we have integrated this sensor. As I said, the sensors are connected to a data logger, which is getting the data and managing it. And it sends the data to the SCADA system through fiber optics using the OPC UA protocol. In SCADA, we have another OPC UA server, which through the OPC connector is sending the data to our PEP platform. And the data from the sensors, you can see here, equivalent noise, and the maximum and minimum level of noise. Within the data, within the PEP platform, we have the database with all the data stored, and we have also the data available from the noise meters digital tools. In the next slide, I'm going to show you in a video all the details of these tools. Started. Okay. So as you have seen before, we have this tool to see all the type of sensors and specific sensors deployed in the Port of Valencia. In this case, we have the noise meters, and if we see the attributes, we can see the real-time values, the real-time measurements, and also other static data like the position, the brand, the sensors, and other kind of information. Then, if we go to the database, we can select all the data about the noise meters, and we can see that we are receiving all the data. In this case, we can see the last value and the date when we recorded this video. And after that, we are going to show you a dashboard in order to show to the Port Authority the information about the noise meters. We can see a map with a real location. We can automatically include other sensors, or if we move them, it's updated. And we can see here some indicators with the real-time data with the last measurements. We have also information about the historical data from these sensors. For instance, the equivalent level of noise for these sensors. We can select one of them if we are interested in only one. We can see with more details the data. We have also information about the maximum level and minimum level of noise from the 3 sensors. And also as the wind could affect the noise propagation, we have included in the same dashboard some information about the environmental control stations. You can see here the real-time wind with the speed and the direction, and also some historical information, in this case, from the last 3 days. And that's all for the deployment in the Port of Valencia. Let's move on now to the Port of Piraeus.
Thank you, Pablo.
Maybe you want to share your screen, or I can...
You can go on. I mean, it's okay if it's okay with you. We have set up and installed in the area of the port 5 micronoise monitoring stations equipped with meteorological sensors, as mentioned before. What we are currently measuring are the LDIN and LEC and all these 10 parameters, 12 parameters that you can see there. So we get them, and they're computed also with historical data that are received from the port. And we have developed an intelligent mechanism for distinguishing noise source by taking into account noise levels in different ranges and frequencies. These data will be also, we're going to use also the vessel traffic data that we're anticipating at the moment, and we will use them also for the predictive algorithms developed so that we can have also forecasting for 24 hours regarding the noise levels. Can you move on to the next slide, please? Okay, so here we have a repetition with the previous use case. So it follows the same logic, the whole architecture of the noise monitoring solution, since they are also fed in the data integration engine, and then the visualization applies, and the predictive engine is going to support the whole solution. At the left side of the screen, you can see where these sensors are installed in the port area. As mentioned before, they have been installed in 3 different areas: at the entrance of the port, at the cruise, and the containers terminal. So next slide. You can see here the several dashboards that the platform represents. So the data flows to the PEP platform coming from the mobile and the air quality sensors, and the external noise sensors are depicted here. And I think that we can move on to the final one, which is the video, Pablo. Yeah. So that everybody see how the devices are listed and what's represented there, and the noise levels visualization. Okay, so you can focus and go deep and see what the levels are and what the peaks are. They can also be exported. So I'm not the technical, Katerina Georgiou is the brain behind this solution. So you can zoom in, you can download, you can export and import the data, and you can get any report on real time. Okay. So thank you. Just a final comment here, that the whole application, the whole solution has been designed under the scalability, the flexibility, the security, the extensibility, and the interoperability concept, so that it can be integrated at any third-party legacy system or any other software, so that it can be replicated from other ports. Me personally, as a project manager of another European project, I know that they would be really interested to adopt what Green Seaports has, the Pioneers project actually, what has been developed in Green Seaports in terms of common operational picture, capabilities. So it would be a nice approach if we can also sustain the result of this project and assure its sustainability and extensibility. So thank you.
Thank you very much, Pablo. Thank you, Katerina, for your excellent presentation. Before proceeding to our next presentation, our next case study, maybe we should have a 1-minute break to put the laptop. Okay, are you ready? Okay, just a 1-minute break so we can install the computer with the platform for the next speaker. Thank you.
Just a second.
Everything ready? Okay, okay. Okay, I will start introducing.
Yes, yes.
Okay, so, okay, thank you. Our next case study number 5, is on forecasting ship-to-shore crane productivity. Mr. Andreas Granwald and Mr. Russ Reinhardt are the presenters from DPH. I warmly welcome both. Mr. Andreas Granwald is a branch manager at DPH office at the deep water port in Wilhelmshaven.
That's right.
Oh, yeah. Andreas is a specialist in port processing analytics, optimization, and risk management. Russ Reinhardt is a team manager in software development of port solutions at DBA with more than 20 years of experience in software business. Okay, so thank you. Andreas, I believe you start first. Okay, the floor is yours. Thank you.
Thank you. I'll have to start the presentation here.
Yes, of course. Here you go. I will put it on.
And to go over, I have to only enter.
You.
Page. Okay, thank you. Oh, thank you. Oh, thanks a lot, Annalena. So sorry I'm a little bit late today, but I will try to give speed here in my presentation. So, as Annalena said, we have prepared a short presentation about our activities in the case study 5, and we have 4 topics, and I will present topic number 1 and number 2, and my colleague Reinhard will present the topics number 3 and number 4. So, to the topic number 1, the whole story at a glance. I think you know this from the morning. What are the main problems addressed? I think it's nearly the same in the other, like the other case studies. So we have the problem that maritime ports are affected by eventual conditions like waves, movement, currents, and that make difficult the loading and the unloading of the vessels in a time. So consequently of this, when there are movements of the ship due to bad weather condition, productivity decrease notably. And that means lower productivity levels, that we have increase in the quantity and also of the emissions and noise and other eventual externalities. That's the reason why we work in this work package case number study 5. And the actual situation and the outcome, I think you know also this from the morning's presentation. I think that is currently digital connection between meteorological information systems and port operation systems are limited, and comprehensive cross-system link has to be created yet. And that's this for the port manager, so they are not able to inform or to alert the stakeholders in time, and that's is one of the problems we try to solve in this case study. And we try in the case study 5 to fill exactly this gap by connecting the relevant systems and combining and try to generate a productivity forecast for 44 hours, that means 2 days in advance. And the results should be the burst windows can be adjusted, turnaround time is short needed, emissions reduce, and resources are optimized. So I think this is also the slide you have often seen in the morning. We have on the left side the incoming information, means the tide wave data, meteor data, and port communication systems informations. And all these informations are collected and will bring by technical form in the PEP platform. so able to make predictions, to make role-based analytics, and to reports and suggestions to the user we have in the ports business. And when we have a look, and I think this is quite interesting of the actual situation in Germany. We have here the slide and a picture from the north part of Germany. On the left side in the yellow frame, you see the quite new deep water port in Germany, in Wilhelmshaven. It's the only one we have in Germany. And on the right side in the yellow frame, you see the port on the north port in Bremerhaven. I think that's in the moment better known than Wilhelmshaven, but Wilhelmshaven is growing up for the next years. I'm very sure of this. And you also see on this screen the existing meteorological environment we have on the coast. So that means, different to the other presentations in the morning, we have no special sensors installed in the port. So that means we're using existing things we have in different places. You see and the bubbles here on the left and right is like chimney. There's water stations. We're using the information from this. And so this makes it a little cheaper. So we have different local land-based meteorology stations installed in party environments. You have seen this in the stream before. And this is connected with different weather services. Also, we have satellites with information we can use. We have this red one, this water level stations will bring information to the system. And we have also different meteorological forecast models we can use to make our work. So I will go a little bit more deep in some package. We have exactly 4 packages, which information we can use for our work for in the case study 5. So the first one is this basic packages, which will deliver information about temperature, felt temperature, snow fraction, and so on. This is information coming from this basic package. And the next one is the C package, which will deliver information about, for example, wind wave direction, sea surface temperature, wind wave high. So all this information, also mean wave direction, we put in the system you have seen in the screen before. On the third, we have this cloud packages, will deliver information about the clouds, low clouds, mild clouds, high clouds. All these things could be bring information for the system. And on the last but not least is the Thai high water packages, which will deliver information about the medium flow, the medium low water, and all this information will come from these packages to our system. So all the 4 packages together, so we find an advantage by using this environment in the use study 5. So we try here, it's like a pig, you save cost savings with, I think it's golden euros will come in. So because there's no installation required on site. And so the required weather information data is available almost everywhere through external providers in Europe and behind by satellites. Try this on this picture to show. And also it's possible to have a quick and easy integration in other technical port environments. Only an adaptation of the input interface or change of GPS location is required for this. And last, we have also additional weather parameters can be implemented without expensive sensor installation if this required. So this is the information I will bring to you for an overview. And I think now my colleague Reinhard will go a little more in deep and will show how the system is working. So let's say information to the system architecture and also, I think, the live data presentation. Okay. Thank you.
Before I start with that, hello everyone. Before I start with that, I would continue with this presentation. So, okay, it's staying there. About the system architecture and how we put this all together. I think this is a similar presentation as we had from the Port of Valencia, but with different content. On the left upper hand, you see the data sources for environmental systems, like the DWD, which is the German official weather service. Meteo Blue is a service which is worldwide acting, where you can buy all these packages Andreas just has shown. You can really get these information for all parts of the world. So the idea of integrating this system to another place or transferring it with Meteo Blue is quite straightforward. The German BSH, they are surveying the tidal and water level. So these are the main important data we need for the German coast. And on the left upper side, we have the parts of the port community system. That means the container orders, the ship calls, what we need, so the plan of what is expected. And as we have said, we have adapters that make these data available to the system. We've heard this from Port of Valencia. They have different connectors, and that's what we also did. We all put this together in a message bus and collect all the data in a big database, to access it for analytics and prediction. And this should indicate what we have already done and where we are working on. So we are working on the analytics stuff with the data, and we did a lot of explorative data analysis. We tried to build up prediction models from these analysis, and to try to bring up data models that represent what the user wants to know. So the aim is to generate dashboards or to integrate it into foreign systems and extend it to whomever wants to know something. And the log should show that we have also paid attention to secure and safe data connections. This is the, let's say, map behind. This is all running on a, technically speaking, Docker service. So we have a lot of small programs, small services running. They can be transferred easily to different environments, to different new locations that want to use this system. This is very much straightforward and well known to all those who are technically involved into such systems. The last thing is now that we want to show how this looks like and see what the dashboards provide. We have two use cases. We have said, or Andreas has said, we are trying to predict the ship-to-crane productivity. But what does that mean? What is ship-to-crane productivity? When is it productive? And the most simple way to everyone would use is how many containers per hour. This is the performance, the main performance factor of a port. But this is not the only one. And just to measure the performance of a port only by counting containers is not the optimal one. So if you don't have so many vessels at berth, then it's very uneconomic to use all the cranes to get immediately all the containers from the ship, and the ship had to wait for another 2 hours to leave the port because it can't be forwarded earlier. So there's a difference between optimal and optimal in the sense of economic optimal. And that makes it difficult to estimate what is really productivity in that way. But we tried, nevertheless, to predict the container movements, including the container announcements, including the announced ship calls, including environmental data, context data, as you will see soon, like shift changes. If in the terminal they are changing shifts, then it takes several more minutes than 1 or 2. The driver of the crane has to come down, the next one up, they have to exchange themselves. So there are 10, 15 minutes, 20 minutes where they're not operating. And this has more impact maybe than the weather. And another thing was, when we tried to find out what container prediction means, is if you rely on ETAs of the vessels, then you are failing a lot, because the ETAs of the vessels are only estimated values that are not really, let's say, not real. They are expecting to be earlier, and they are, let's say, optimistic in what they are doing. So if you plan the berthing and the unloading of containers, and you start with false data of the vessels, then it doesn't help you, because all your computations, all your predictions might be wrong. So the first thing, what you need is to get better ETAs. So the announced ETAs of vessels, they have to be revalidated concerning the parallel arrivals, the wind and current and all that. So the environmental things are as important as the, let's say, berth situation and the movements. And in Bremerhaven, as you have seen on the map from Andreas, it's very close. So if you rotate a vessel, then during this rotation, there must not be another vessel arriving or passing through. And this has to be taken into account when you predict the ETA. And it's not only the distance, because it's not an open berth where you come from one side and the other. It's Bremerhaven is on the riverside, and you have to turn the vessel that way that it can, in the case of emergency, quickly emerge from the port. So it has to be turned around. And now we could switch to the other screen if you can. It looks alike, but this is actually live data from a snapshot that I put onto my computer. What you could see here is the dashboard for the container movements per hour. On the left hand, or the idea behind that is, in the middle, it's the current time, it's now. On the left hand, you see the past week, and in this presentation, we still have the forward for the next week, but it will be reliable only for the next 2 days. It's the same with the weather. The forecast for 7 days is very, very unlikely, so we will reduce this. But what you could see here is, on the upper hand, the number of containers per hour, and what you see very, very nicely here is the impact of shift changes. Every peak down is a shift change. And this reduces the number of containers in that hour immensely. On the next level, you see the weather conditions, like the pressure, the air pressure, and the water level in the lower corner. And on the right hand, it's the forecast taken from the forecast of the meteorological systems and from our AI. In a normal case, it's more like that. There is no big difference, and it's very randomly. So this makes it very, very difficult for us to find some model that really predicts container motions. But for example, in this case here, which is, I think we heard this date this morning, in the middle of February, we had a very, very strong storm in the North Sea, and we had very heavy wind, and the air pressure fell very, very quickly, and you see this here. This was the way it fell, really. I'm sorry. This means that there was heavy wind, which is the yellow one here. And during this heavy wind, they could not operate. And this is represented here because you can very, very good see the relation here that with very strong wind, you can't operate. But to be honest, this is one of the only really predictable relation. If you have very strong wind, more than 8 Beaufort, for example, then you can't operate. And below 8 Beaufort, the operation is more or less normal. So there is no difference if you have strong wind, like 6 Beaufort, or you have no wind, the container movements are not influenced very much from that. So we're still working on finding in the data analysis, finding ways of how container movements are related to weather conditions. And we are not at the end, but our models, you have seen the numerous data that Andreas presented. It's a vector of, I think, 50 data, but none of them are really crucial to container movements. So let's switch to the other one, which is more interesting. This is the second use case to predict the ETA quality of data. So the ships arrive, we have an expected ETA, and we get all this data and immediately calculate if this is reliable or not. And the first rows, you see the ship name, you see the IMO number, and then you see the type of the ETA, of the estimated time of arrival. We have a so-called ETA loose and ETA fixed. The ETA loose is, 2 days before, I expect to be there at over next day, 6 o'clock. And the ETA fixed is after communication with the port authorities where you have this fixed data and you're about to arrive at that time. For each of those data, we calculate our deviation of that. So what you could see in the colored bar here is the degree of deviation that we expect. So for example, this Malik Arctica vessel here is expected to be 7.8 hours later than they are expecting to be there. This means it's really a great deviation. Others, like minus 10 minutes or plus 1 hour, I think this is something they operate with. But this is the way our data models really put out. So we get all this in, we get all the meteorological information in, we get all the parallel arrivals in, and therefore we expect this is not a very reliable value. And in the last column, you see the, let's say, reliability. How probable is that it will be reached, or how good is the forecast? So if we have a forecast of 70%, it's like the rain probability. You all deal with, if you have a rain probability of 20%, you will do your party outside. If you have a rain probability of 80%, you will try to plan, well, let's go inside. But if it will actually rain or not, this is not given by this probability. It might happen or not, it's 1 or 0. But this is an indicator of how reliable these data are, of how good the data quality was, of how good the data, the input was. And together with these AI calculated data on the right hand here, we show the current weather situation, the current tidal situation below, where you can see the tidal level together with the expected wave height. And these are as well forecasted data from the Meteor Blue system, which forecasts it, I think, 3 days, 4 days before. And this is our current application, what we have as dashboards. We are still presenting this to the stakeholders, and we are still finding out who's really interested in having this information. Of course, it's the port authority that are handling these data, but the carriers as well, and it might even be the forwarders, that they know if their containers are delayed or will be delayed, and if the vessel is about to arrive 1 day later than expected, then it's interested for them. Okay, that's my finish, and I think thank you for your attention, and that's it. Thank you.
Please, Reinhard, have a seat here if you want to.
Okay.
Okay, thank you very much, Andreas. Thank you very much, Reinhard. I am immediately proceeding to our last case study number 6. I would like to invite Mr. Jesus Blanco. He's joining us online. He will present the case study on behalf of Balearia, measuring real-time emissions along a multimodal transport chain. Jesus is a naval architect and marine engineer. He is responsible of projects on. He's responsible on various projects concerning fleet technical area, LNG retrofits, fleet control tower, and he's also acquainted with the maritime regulations on energy efficiency and emissions. Jesus, can you hear us? Hello, welcome. You have the floor. Can you
Hi.
share your screen
Yeah.
with us?
Yes, can you hear me? Hello?
Yes, one moment. Yes, we can hear you.
Okay.
Can you share your screen with us?
Yes, I'm trying to share it now. Tell me when you can see it. Okay. You can share it?
Yes, perfect. Thank you. The floor is yours.
Okay. Good afternoon to everyone. First of all, I want to thank the Port of Piraeus and the Fundación Valencia Port for having the opportunity to participate in this great event. Now I'm going to talk to you about the case study number 6, measuring real-time emissions along a multimodal transport chain. Firstly, I'm going to give you a brief description of the case study 6, and to continue, I will tell you about the equipment and sensors installed on board the vessels and vans. I will end explaining the integrations that we have done with the PEP platform. Okay, we look towards to have the door-to-door carbon footprint of all products and materials to be purchased in supermarkets. For that, we measure the real emissions generated in the door-to-door transport chains by measuring vans and ships emissions. As ferries arrive ports every day, they are an important emission source, so we must work in reducing them, starting by measuring the emissions. For that, we install sensors on board the vessels and in the transport vans. Here you can see the 5 Balearia vessels that have been sensorized: Bahama Mama, Sicilia, Cecilia Payne, Marie Curie, and Eleanor Roosevelt. We sensorized 3 conventional ferries and 2 high-speed crafts. Some of them are consuming LNG, others are consuming marine gas oil. So we have a mix there to make a comparison. In this slide, we want to represent the general concept of the ship sensorization and the data sources that we use. We install on board torque meters, gas analyzers, flow meters, GPS, draft sensors, accelerometers or inclinometers, and we made some integrations with some of the ship's systems, such as bridge and automation, bridge equipment and automation system. All these data sources are connected in a ship platform where all the data is uniform. Here is a high level of the onboard architecture, where you can see that onboard sensors send information by Modbus TCP protocol through a new Ethernet network that we have to install on board our vessels to the onboard server. In this server is running Elastic, which is a tool that lets us to interpret, clean, and store all the data that we receive. And then through Logstash, the data will be captured or sent to the centralized data lake. Also, in a high level, you can see here the data management. On board the 5 vessels, we install the sensors, and then all the info, all the data on board the sensors of these vessels are sent to the centralized data lake. In the data lake, all the data is filtered and checked, its quality, and here is where we can do computations, analytics, and predictive models. Then in our control tower platform, we can have the KPIs and dashboard that let us manage this data and make decisions on how we can operate the vessels to reduce the emissions. Now I'm going to start talking about the sensors that we installed on our vessels. The first one is the gas analyzers, the SEMs, with the continuous emission monitoring system, which were installed in the main engine's exhaust pipes. In each vessel, the installation is different, as every exhaust pipe or machine space is different in every vessel. The maker for this equipment is Green Instruments, and the model is G7000. With this equipment, we receive real-time emission measurements of CO2, SO2, NOx, O2, and the NOx-SO2 ratio. Here you can see some pictures of the real installation on board the vessels that we made. The next sensor that I'm going to talk about is the flow meters, which were installed in the main and auxiliary engines, inlet and outlet pipes. Also, the sensors and all the sensors in each vessel, the installation is different. Every pipe or machine space are different, so we have to adapt it and do a particular project in each vessel. The maker are Bath Instruments and the model are the PT2 series. With these flow meters, we can calculate the real-time consumption of the engines. Here you can see also some pictures of the installation. For the installation of the flow meters, we need to install a bypass in each line. So if something is going wrong with the sensor or it gets blocked because of something, we can make maintenance and the flow meters without stopping the system or the engines. Then we also install torque meters that were installed in the shaft lines that will give us the torque and shaft power, calculating the engine's power in every moment. These are also Bath Instruments sensor, and the model is the T-Sense. For draft sensors, we install them in the bridge wings, one in the aft, in the starboard or port side is the same. The maker is Becca, and with them we get the measurements of the draft in a continuous level measurement. Here you can see some examples of the installations in our vessels. Okay, another is the inclinometer or accelerometer sensor, which is installed on the bridge. The maker is Redkite, and with this equipment we receive real-time measurements of dynamic trim in combination with draft sensors, and also accelerations and the roll of the ship. And to finalize, the last sensor that we install on board is the GPS, which we install it in the bridge. It's also Redkite maker, and it's a differential GPS. And with it, we get the position of the vessel with a precision up to 5 meters of error. Also, we made some integrations with some systems of the ship, such as the bridge equipment, to have more information about the operative of the ship, such as the speed, course, wind force, and direction, and with the automation system, to have more information about the engine parameters of the ship, such as exhaust temperatures, pressure, tank levels, temperatures, all these things. In these slides, I want to show it quickly. We want to show the type of sensor and the quantity of them that we installed in each vessel. In Bahama Mama, we installed 1 Thames, 12 flow meters, 2 torque meters, 3 draft sensor, 1 inclinometer, 1 GPS, and we make the integration with bridge and automation system. Here are the same for Sicilia. It changes a little bit the quantity of flow meters. Eleanor Roosevelt, Marie Curie, and Cecilia Payne. Now there are the sensors from the vans. In collaboration with Inerco, Gas2Move intended to install light Thames in their vehicles. A thought market search has revealed that there is no technology available with the required specifications, mainly in terms of lightweight and low volume. So a new approach is necessary to measure gas-to-move vehicles emissions. The emissions from gas-to-move vehicles were measured in the test lab in ERCO under different load and speed conditions. Then those vehicles were monitored during several trips, emulating real-life operation, capturing explanatory data such as speed, acceleration, engine's performance, load carried, as well as real-time emissions. Finally, with all the above results, INERCO modeled the emissions of the vans from indirect data captured in real-time actual operations, acceleration, speed, engines, performance, etc., in order to associate emission values to real transport operations carried out during the trial period of the project. Here you can see how gas-to-move and INERCO done this a test with the emission monitoring equipment and the vans. Now I'm going to explain the sensors integration with PET platform. I'm starting with a small demo of the onboard platform that is on the ships and how it looks like. Let me start. See if it's working. I'm not sure. You can see it. Yeah. We are going to see the data of one vessel. We have two different types of dashboards. These first ones are the ship's dashboards that they have always on their computers. The first one is the bridge department dashboard, where they can choose the important information for the captains, such as the speed, drafts, trims, roll angle, consumption, main engine powers. They also can customize the data for the time range perspective. And this one is the engine department dashboard, where they can see the most important information for the chief engineer. Draft, speed, consumption, engines power from main and auxiliary engines, thems, emissions. And then we have also another dashboard where all the data are in the graphics. All the data from the sensors goes inside and it has a graphic, and you can change the time range, and all the data will update accordingly. So here we can do also some performance and some studies. Here you can see a high-level integration with PET platform, where Balearias and gas-to-move data is integrated in the PET platform. Now I'm going to go a little bit deeper in the integration. These integration figures are similar to the ones used by Fundación Valencia Port. I'm not an expert in integrations, such as Joan Meseguer or Paulo Jimenez, but I will try to briefly explain them. Balearias vessels gas analyzers equipment send the data through satellite communication to a cloud platform. Then from the cloud, the vessel data is sent to the Node-RED middleware in the port using HTTPS AP reset. Node-RED middleware translate message to P format and send them to the PEP platform. Okay, here is the time of gas-to-move data, which is done in a similar way. Gas-to-move vans devices send information through 2G or 3G communication to the cloud platform, and then from the cloud, the vans data is sent to Node-RED middleware in the port using API reset. Node-RED middleware translate message to P format and send it to the P platform. And I want to show you a small demo of the P system of Valencia Port, where you can see all the sets or digital twins of Balearias vessels and gas-to-move vans monitorized data. Here you can see the data archive of P system, which is the database where all the information sent from the vessels and vans are stored. This vans information. with the values that we receive from the vans or the vessels. You can see all the information sent is in this P system from Valencia Port. And here now you can see the graphics for all the assets, vessels and vans of all the information on monitor sites, such as emissions and cargo data. And well, and this is all from my side. Thank you for your attention.
Thank you very much, Jesus, for your presentation. We have now concluded with the presentations of all case studies. As you can see, all of them are following more or less the same methodology, but the actual technical implementation is totally different for each one of them. At the end of the day, the outputs are apparent and are expected to support the mitigating of emissions in ports and optimizing environmental management. I will go to the last presentation before the concluding remarks. I will invite our coordinator again, Mrs. Eva Perez from the Valencia Port Foundation, to share with us the current status of the project and the next steps to be followed. Eva, can you hear me?
Yeah, hello.
Thank you. You can share your screen. Great.
Okay, so let me put it in full screen. Can you see it?
Yes, we can see conclusions. Is that
Okay,
correct?
perfect.
Okay.
Yeah.
Thank you.
Actually, this is going to be a very brief presentation just to talk about the ongoing work that we are doing, the future steps, and then I'll quickly give you a thank you note. So, well, going back again to the general scheme of green seaports, we can see that we have concluded activity 1, where we have implemented new sensor networks and have integrated this network and pre-existing systems in a newly created port environmental platform. So this has already been finished, and now we are deep into activity 2. And in activity 2, we are applying artificial intelligence predictive modeling to 6 case studies, the ones that have been presented more in detail by my colleagues before. So what we are doing is we are using big data source analysis. We are treating large amount of data using exploratory data analysis, and we are also preparing the data sets. It's important to identify outliers, errors. All the data sets may be coming in different formats that we need to standardize. So we are doing all that preparation so that we can treat those data sets using artificial intelligence models for prediction. We are splitting the data sets in training and testing data so that we can use different tools on the training models and then compare them with the testing data. And as a final task, we are doing an evaluation on the performance of our predictive models. We can use different metrics like mean absolute error, root mean square error prediction. We can use all these metrics to check the quality of the models that we are estimating, and we can obviously compare them to the reality that is occurring a few days later, so that we see what's the accuracy of what we are predicting. So that's ongoing work. Future steps will be sharing real-time data and the predictions with internal and external users. We are already creating APIs to share this information with external and internal users. And again, we've already started defining the kind of reports, the kind of information that they want to receive. Concerning communication, there are upcoming events in Bremen focusing on big data modeling and advanced predictive analytics. Here we are going to present the results of activity 2. Most likely, this event will take place also in hybrid format at the beginning of 2023. The next event will be in Venice in Q2 2023. It'll focus on reporting modules and reporting pilot results. This will be the results of activity 3. And finally, the final communication event on green reports will take place in Valencia and also in hybrid format in summer 2023. We'll also elaborate final report with all the results and the policy recommendations and will be publicly available. So we welcome you to our events. We welcome the audience to our events. Stay tuned. You can follow our progress in LinkedIn, Twitter, and other networks. And I would like to finish these conclusions with a thank you note. Thanks to our SAINIA project officers, Sofia Papantoniado, who was our project officer until a few months ago, and Stefano Campagnolo, who is supporting us and monitoring our progress now. Many thanks to Stefano Campagnolo as well for accompanying us today and for his presentation this morning. Thank you very much to all the organizers of this event, to the Port Authority of Piraeus, Municipality of Piraeus, and the other Greek partners that have also contributed, ICCS, Send Travel, Glomar, for the organization of this successful event. Congratulations, because it's been very well organized, and we hope that those of you who are attending in person are enjoying not only the technical sessions, but also the networking opportunities that a physical event provides. We hope that you're enjoying also the weather, the food, and the hospitality of our great Greek partners. Finally, many, many thanks to all our partners for all your good work and the progress made. Let's keep up the work now, because we have reached the core phase of the project. So the following 12 months are going to be decisive, and we need to make our efforts really show good results at the end. We will keep in contact in virtual working meetings and hope to see you in our events in Bremen, Venice, and Valencia in the next coming months. Thank you very much.
Thank you very much, Eva, for your inspirational conclusions. I will open the floor in case someone would like to share a question, either physically or online, before going to the concluding remarks. Do we have any questions on the last session? Online?
We don't have any questions from online.
Great. Yes, Katerina.
I do have a question for both of you there, Andrea, and apologies, I don't remember the second name.
Reinhard.
Okay, great, thank you. So I really loved what you have presented, and I was curious, how can we, the rest of the partners that are currently, let's say, working somehow in parallel, gain some experience or know-how from your side related to the predictive, let's say, models developed? Is there any possibility that we can go through the platform and navigate and see what's in there and get some inspiration?
Oh, is it on? Yes? Maybe?
No.
Now it's red light.
Yes, yes.
I hope you can hear me. Yes, we are currently working on this, and this is not exposed to the outside world for the moment, but we are just working on making it available, let's say, for the first group of the project partners. I think we should do that. What you see here is just a snapshot of data we took to make this presentation here. Oh, thank you. But concerning the ideas behind the modeling and the learning technologies and all that, I think we should really start off working together, because this is something I really find inspiring, that together with Joan, who's very much expert in artificial intelligence and in modeling and all that, and together with other guys from our company and ideas, we try to find out where are relations, and we found, unfortunately, that between certain data we expected there weren't relations and all that. So of course I would like to have an exchange of methodology and technology and how we do this. So I think we should really start this, because currently every case study is working on their own. There are some case studies that are interrelated because of the same goal, but others are not. And we are, during the day I learned that weather and ship forecasts are even for Venice. I think there were information with another focus, but they also had this requirement to have good ETAs and to see how the situation comes along in the next few days, together with meteorological data. So I think we should start having work groups and start something. I think Joan has introduced an AI working group, I think 1 year ago. He tried to initiate something, but it hasn't really, it was too early at that stage, because no one was really working on that. And maybe we should take him as a coordinator, because he's keen on working with AI things. I think he will be a good one to coordinate things.
Okay, thank you.
Thank you very much, Reinhard. Thank you, Katerina. Okay, if we don't have anything else, I will conclude with the session, and I will now pass to our concluding remarks and our final speaker. I warmly welcome our host and the organizer behind today's conference, Mr. Dimitris Spyrou, who is the responsible of EU projects at the Port Authority of Piraeus. Dimitris.
So, closing. Dear ladies, dear gentlemen, dear participants, it is true that it has been quite a long day today. First of all, I would like to thank you all for attending and participating in our conference today. I would like to thank the speakers, the honorable guests, and of course the moderator, Ms. Anna Leka, for her perfect support and work. And of course I would like to thank also our consultant, Thanasis Chaldeakis, who did a lot of work all these days, to support towards this successful event. All presentations highlighted the importance and innovation of green seaports in the best possible way. Nowadays, port infrastructures are considered an integral part of coastal cities, with port operations having an important impact to the environmental quality of the neighboring areas. Local authorities and port managements need quick and accurate information in order to adopt mitigating planning. Taking into consideration such concerns, green seaports can be considered as a pioneer in the implementation of green technologies and applications in the ports of Europe. The array of digitalization tools and technologies developed within the project can pave the way to new approaches supporting port environmental sustainability. Due to this novel content, Green Seaports was awarded with 2020 World Port Sustainability Award of the International Association of Ports and Harbors under the category Resilient Infrastructure. As the speakers have presented before, The project addresses 6 business cases consisting of prototypes and pilot tests that are implemented in different European ports and that serve as a basis to test innovative technologies such as IoT, big data, or predictive analysis using artificial intelligence models. The project will reduce the impact of port operations in cities, control emissions from ports and ships, and optimize cargo handling in the main European ports. In this sense, the project promotes ecological, viable, attractive, and efficient maritime transport links integrated through the transport chain, and its application contributes to rebalancing the EU transport system towards a more sustainable system. Overall, Green Seaports promotes low-carbon transport with the aim of achieving by 2050 a significant reduction of CO2 emissions in line with the relevant Union CO2 reduction targets and promotes the evolution of core ports in the European maritime industry to zero-emission operative model. As dear Eva stated before, we are halfway through. However, the progress noted until now is substantial. We'll continue our good cooperation and implementation until the mid of 2023. And from our side, we invite all of you to follow our progress. We are available for any further question or information. Again, I thank you all for being present, and a big thank you to the whole organizing team for realizing such a successful event. I hope to have the opportunity to see you again in the future. Thank you very much again.
Thank you very much, Dimitri, for your warm farewell. Okay, our conference has come to an end. I would like to sincerely thank all the speakers, the contributors, and the participants for your physical and online presence and your patience. It has been a pleasure being here today. If you have any questions or comments, please feel free to contact the consortium through the official website or any of the partners. So, yes, goodbye to everyone. Thank you very much. A big thank you to all the IT at the back of the room. You were wonderful.